As the Chinese proverb says, a journey of 1,000 miles begins with a single step. Today's a big day. You're taking your first step in your journey to learn how to write scripts in Python. It's going to be a little challenging at times, but really it's not that scary. We'll go slow and give you everything you need to fully grasp each concept before we move along. In the next few videos, we'll discover the fundamental concepts of computer programming. You'll learn what a programming language is, what scripting is, what languages are out there other than Python, and how this all relates to IT. We'll also have you coding before you know it, with small coding exercises we've cooked up to give you hands-on practice with Python. This will include writing your very first Python script. But always keep in mind, if at any point along the way you feel lost or confused, don't panic. You can watch the videos as many times as you need to let the concepts sink in. When I was asked to participate in this program, it made me think about when I first started to code. If I could give that younger version of myself a piece of advice, this is what I would tell her. It never works the first time. Seriously, as a newbie, I expected it all to work like magic. I thought that following the rules and getting it right the first time would prove my value as a coder, but that's just not true. Not even the best of the best. If you expect to write perfect code on the first shot, you're going to be disappointed. You hear that, younger self? Try not to feel overwhelmed by the details. Connecting the dots only comes with experience, so best way to learn is to just jump in. The truth is, everyone learns at their own pace. If you already know some of these concepts, feel free to skip ahead to the parts that interest you the most. If you're starting from scratch, take as long as you need for each concept. The assessments will be right there waiting for you when you're done. And if at any point you start doubting yourself, remember, even the most advanced programmers started thinking, Python? What's Python? Well, we're about to learn all about it, so let's dive in. Next up, we'll be doing a rundown of what programming is. At a basic level, a computer program is a recipe of instructions that tells your computer what to do. When you write a program, you create a step-by-step recipe of what needs to be done to complete a task. And when your computer executes the program, it reads what you wrote and follows your instructions to the letter. How nice is that? The recipe is written in a code called programming language. Programming languages are actually similar to human spoken languages since they have a syntax and semantics. Now, if it's been a while since your last grammar class, here's a quick refresher on syntax and semantics. In a human language, syntax is the rules for how a sentence is constructed, while semantics refers to the actual meaning of the statements. In English, sentences generally have both a subject, that's a person, place, or thing, and a predicate, usually a verb, and a statement that explains what the subject is doing. Let's take the sentence, Paula loves to program in Python, as an example. In this sentence, Paula is the subject, and loves to program in Python is the predicate. To form a sentence that others can understand, you need to know both the syntax that constructs the sentence and the semantics that gives it meaning. The same applies to programming languages. In a programming language like Python, the syntax is the rules for how each instruction is written, and the semantics is the effects the instructions have. Much like spoken languages, there are lots of programming languages to choose from. Each has its own history, features, and applications, but they all share the same fundamental ideas. So once you understand the basic concepts in one programming language, it becomes much easier to learn another. And lastly, computers always do exactly what they're told. So when you write a program, it's important to be super clear about what you want the computer to do. Learning the syntax and semantics of the programming language you choose will allow you to do just that. Make sense? Before we continue, let's spend a moment on terminology. In the next few videos, you'll hear the term script being used a bunch. So what's the difference between a script and a program? The line between the two can be a bit blurry, and in this course, we'll use the terms interchangeably. In general, you can think of scripts as programs with a short development cycle that can be created and deployed rapidly. In other words, a script is a program that is short, simple, and can be written very quickly. In this course, we'll focus on a specific scripting language called Python, which we'll use to learn the basics of programming. We'll learn about the Python syntax, the rules of how to write a Python program, and the semantics, or meaning, of the different pieces involved. Before we start learning how to code and having you write your first Python script, let's talk more about what automation is and why it's useful. Although we might not realize it, we reap the benefits of automation all the time in our daily lives. Do you ever pay your bills with scheduled payments or use a self-checkout at the grocery store? I always set my coffee machine to start brewing before I've even gotten out of bed. The promise of fresh coffee makes early mornings way easier. Automation is the process of replacing a manual step with one that happens automatically. Take a traffic light, for example, which continuously regulates the flow of vehicles at an intersection. A traffic light requires a human intervention only when it needs repairs or maintenance. The automatic regulation of traffic means that humans don't have to stand at the intersection manually signaling when cars should stop or go. Instead, people can concentrate on more complex, creative, or difficult tasks like focusing on where you're driving. What's more, traffic lights don't get tired, bored, or accidentally display a green light when they met red. This highlights another benefit of automation: consistency. Let's face it, us humans are flawed and sometimes we make mistakes. A human performing the same task hundreds of times will never be as consistent as a machine doing the same thing. But for all of its advantages, automation isn't a solution for every situation. Some tasks just aren't suited for automation. For example, they may require a degree of creativity or flexibility that automatic systems can't provide. Or, for more complicated or less frequently executed tasks, creating the automation may actually be more effort or cost than it's worth. Think about when you get a haircut. What would it take to automate the actions of cutting hair with a machine? The client's height, the shape of their head, their current hair length, and desired hairstyle would all need to be taken into account when designing the automatic system. We'd need to replicate the creativity and skills of a trained specialist, along with extensive testing to ensure the client's safety and quality haircut. And if you've ever had a bad experience at a hair salon, you know quality can be subjective. In this case, the cost and effort of automation just isn't worth the benefits of an automatic haircut would provide, which is why we don't have robot hairstylists. Not too complex, right? Automation is a powerful tool when used in the right place at the right moment. It can save time, reduce errors, increase consistency, and provide a way to centralize solutions and mistakes, making them easier to fix. Throughout this course, and in upcoming ones, we'll be talking about when it makes sense to apply automation and exactly how you do it. Eventually, knowing when and where to use automation will become automatic for you. Working in IT, a lot of what we do boils down to using a computer to perform a certain task. In your job, you might create user accounts, configure the network, install software, back up existing data, or execute a whole range of other computer-based tasks from day to day. Back in my first IT job, I realized that every day I came into work, I typed the same 3 commands to authenticate into systems. Those credentials timed out every day by design for security reasons. So I created a script that would automatically run these commands for me every morning to avoid having to type them myself. Funny enough, the team that monitors anomalous activity discovered my little invention and contacted me to remove it. Oops. Tasks performed by a computer that need to be done multiple times with little variation are really well suited for automation. Because when you automate a task, you avoid the possibility of human errors and reduce the time it takes to do it. Imagine this scenario. Your company had a booth at a recent conference and has gathered a huge list of emails from people interested in learning more about your products. You want to send these people your monthly email newsletter, but some of the people on the list are already subscribed to receive it. So how do you make sure everyone receives your newsletter without accidentally sending it to the same person twice? Well, you could manually check each email address one by one to make sure you only add new ones to the list. Sounds boring and inefficient, right? It could be, and it's also more error-prone. You might accidentally miss new emails or add emails that were already there. Or it might get so boring you fall asleep at your desk. Even your automated coffee machine won't help you out there. So what could you do instead? You could get the computer to do the work for you. You could write a program that checks for duplicates and then adds each new email to the list. Your computer will do exactly as it's told, no matter how many emails there are in the list. So it won't get tired or make any mistakes. Even better, once you've written the program, you can use the same code in the future situations, saving you even more time. Pretty cool, right? It gets better. Think about when you're going to send these emails out. If you send them out manually, you'll have to send the same email to everybody. Personalizing the emails would be way too much manual work. If instead you use automation to send them, You could have the name and company of each person added to the email automatically. The result? More effective emails without you spending hours inserting names into the text. Automating tasks allows you to focus on projects that are a better use of your time, letting computers do the boring stuff for you. Learning how to program is the first step to being able to do this. If you want to get computers to do the work for you, you're in the right place. Earlier in this video, I told you about the first task I ever automated. Now I want to tell you about the coolest thing I ever automated. It was a script that changed a bunch of access permissions for a whole lot of Google internal services. The script traversed a large directory tree with tons of different files, checked the file contents, and then updated the permissions to the services based on the conditions that I laid out in the script. Okay, I admit I'm a total nerd, but I still think it's really cool. Make sure you read what others are saying. They may give you ideas that you haven't even thought of. After that, you're ready to take your very first quiz of the course. Don't worry, it's just for practice. Welcome back. How'd you do on your first quiz? If you got most of the questions right, great job. If not, no worries. It's all part of learning. We'll be here to help you check that you've really got your head around these concepts with regular quizzes like this. If you ever find a question tricky, go back and review the videos, and then try the quiz again. You want to feel super comfortable with what you've learned before jumping into the next lesson. Remember, take your time. I'll be here whenever you're ready to move on. Okay, feeling good? Great, let's dive in. In this course, we'll use the Python programming language to demonstrate basic programming concepts and how to apply them to writing scripts. We mentioned that there are a bunch of programming languages out there. So why pick Python? Well, we chose Python for a few reasons. First off, programming in Python usually feels similar to using a human language. This is because Python makes it easy to express what we want to do with syntax that's easy to read and write. Check out this example. There's a lot to unpack here, so don't worry if you don't understand it right away. We'll get into the nitty-gritty details later in the course. But even if you've never seen a line of code before, you might be able to guess what this code does. It defines a list with names of friends and then creates a greeting for each name in the list. Now it's your turn to make friends with Python. Try it out and see what happens. Throughout this course, you'll execute Python code using your web browser. We'll start with some small coding exercises using code blocks, just like the one you experimented with. Later on, as you develop your skills, you'll work on larger, more complex coding exercises using other tools. Getting good at something takes a whole lot of practice, and programming in Python is no different. We recommend that you practice every example we share in this course on your own. If you don't have Python installed on your machine, no worries. You can still practice using an online Python interpreter. Check out the next reading for links to the most popular Python interpreters available online. Now, I'm sure you're wondering, what the heck is a Python interpreter? In programming, an interpreter is the program that reads and executes code. Remember how we said a computer program is like a recipe with step-by-step instructions? Well, if your recipe is written in Python, the Python interpreter is the program that reads what's in the recipe and translates it into instructions for your computer to follow. Eventually, you'll want to install Python on your computer so you can run it locally and experiment with it as much as you like. We'll guide you through how to install Python in the upcoming course, but you don't have to have it installed to get your first taste of Python. You can practice with the quizzes we provide and with the online interpreters and code pads that we'll give you links to in the next reading. We'll provide a whole bunch of exercises for you, but feel free to come up with your own and share them in the discussion forums. Feel free to get creative. This is your chance to show off your new skills. Although we picked Python for this course, it's important to note that it's just one of the many coding languages out there. Think of a given programming language as just one of the many powerful tools in your IT toolbox. Each language has its unique set of pros and cons. Some run faster than others, some are better suited for enterprise applications, others are particularly good at crunching numbers. There are platform-specific scripting languages like PowerShell, which is used on Windows, and Bash, which is used on Linux. Both are widely used by system administrators on those platforms. There are also general-purpose scripting languages similar to Python, like Perl or Ruby, which are also widely used for scripting and automation. JavaScript, which was originally developed as a client-side scripting language for the web, is increasingly used as server-side for a broader set of tasks. And the list doesn't stop there. There's a vast array of traditional languages to explore, like C, C++, Java, or Go. As you progress in your career in IT, you'll probably encounter a number of different languages and learn when to use each of them. But let's not get ahead of ourselves. First, we have Python to get our heads around. A nice feature of learning the basics of programming in one language is that you can generally apply the same concepts you learn to other languages. This means that once you're familiar with Python, you'll find it easier to pick up new coding languages, as you'll spot and understand similarities and differences between them. After all, every language needs to do some common things like create variables, control the flow of a program, read input, and display output, even if they do these tasks using different approaches. As we called out earlier, learning a programming language is somewhat similar to learning a foreign language. You'll need to grasp the syntax and semantics for that language. Luckily for us, once you know the fundamentals of programming, learning another language is much easier than learning a second foreign language. There are a lot more similarities between programming languages than differences. To explore some of the similarities and differences between various scripting languages, let's take a look at a simple program that prints the words "Hello World" 10 times in 3 different languages: Python, Bash, and PowerShell. As you can see, each language uses a different approach to printing "Hello World." But look closer and you'll see similarities too. Each language must somehow put text onto the screen. The command for Python is print, for Bash it's echo, and for PowerShell it's write host. Also notice that each language has to count to 10 in some way. While Python does this by specifying range 10, Bash uses a sequence notation to count from 1 to 10. PowerShell has the most complex syntax in this example, but it also boils down to starting at 1 and counting up to 10. So, as we've just seen, there's a whole lot of programming languages out there. But don't let that scare you. In this course, you will only need to focus on learning Python. Once you can speak Python, you can go on to learn any other language you want. Up next, we've got another quiz to help you practice what you've just learned. Remember how we mentioned that Python is simple and easy to use? Python makes it easy to express the fundamental concepts of programming, like data structures and algorithms, with easy-to-read syntax. This makes Python a great language to use to learn programming. And there are other reasons to pick Python too. Python is super popular in the IT industry, making it one of the most common programming languages used today. Python isn't new. Its first version was released by Guido van Rossum back in 1991. Since then, the community that develops it has grown and the language has advanced a lot. Whenever there's a significant change to the semantics or syntax of the language, a new major version is released. In 2000, Python 2 was released. In 2008, we got Python 3. In this course, we'll use Python 3.7, which came out in 2018. For many years, Python was considered a beginner's language and was mostly used for teaching concepts or writing very small, simple scripts, like in this course. But in recent years, the adoption of Python has grown dramatically. One reason for this is that the language has become more powerful. It's also because there's more tools available in Python for a growing range of applications. You can use Python to calculate statistics, run your e-commerce site, process images, interact with web services, and do a whole host of other tasks. Python is perfect for automation. It lets you automate everyday tasks by writing simple scripts that are easy to understand and easy to maintain. That's why Python is the language of choice for lots of people working in IT support, system administration, and web development. Not only that, but it's also used in fast-growing areas of IT like machine learning or data analytics. Last but not least, Python is available for download on a wide variety of operating systems like Windows, Linux, and Mac OS. And what's more, Python is so popular in the workplace that if you are currently working in IT, you've most likely encountered it already. And if you're planning a career in IT, chances are you'll interact with Python quite a bit. So, there's a whole lot of reasons for why Python is relevant to today's IT industry. A large part of programming is learning through trial and error and asking questions. So if at any point you get stuck, don't get discouraged. Making mistakes helps you improve. The more you see failure or broken code as an opportunity to learn, the quicker you'll master programming. I remember the first Python script I ever wrote. It took a lot of refactoring, debugging, and testing to get it to work. I relied on a lot of my teammates for help and mentorship and wound up spending more time on Stack Overflow than actually writing the code. Thankfully, you don't have to reinvent the wheel. There's almost always someone on the internet who's tried to do what you're doing and can help point you in the right direction when you're stuck. Sometimes it takes a village. It's really important to keep in mind that even experienced programmers may need to ask a colleague a question from time to time, or look something up on the internet. Whether you're a programming novice or have some experience in software development, remember, the best programmers overcome challenges by seeking help or using other resources. Once you've completed this program, you'll be well on your way to confidently programming in basic Python. There's lots of information online that will help you continue to develop your programming skills. For example, there are lots of online courses for specific programming languages. You'll find answers to your Python coding questions in the official Python documentation. You can use sites like Stack Overflow to discuss and share with other developers. You can even subscribe to some of the Python mailing lists to keep in the know on the latest updates to the language. You're opening the door to the whole world of programming, and it's super exciting to be joining the development community. The most important thing to remember is that you're never alone. Any questions you may have, any time in your career, there are resources out there to help you find the answers you need. Wow, that was a lot of information. Feel free to take a quick break, grab something to drink, and then head on over to the supplemental reading to learn more about Python and the resources out there to help you learn. Now that you've got an idea of what Python code looks like, let's check out one of the most basic examples and dive deeper into what's going on. Get ready. We're going to use a Python interpreter to make our computers say hello to the world. When we run this code, either locally on our machine or on a web interpreter, the words hello world appear on the screen, just like magic. Actually, it's not magic. It's because print is a Python function that writes what we tell it to on the screen. Like the statement hello world, for example. The print function is part of the basic Python language. Whenever we use keywords or functions that are part of the language, we're using the programming language's syntax to tell the computer what to do. So, what are functions and keywords? Functions are pieces of code that perform a unit of work. We'll talk a lot more about functions later on, and you'll even learn how to write your own. Keywords are reserved words that are used to construct instructions. These words are the core part of the language and can only be used in specific ways. Some examples include if, while, and for. We'll explain all of those and a bunch more later in the course. As we called out, the keywords and functions used in Python are what makes up the syntax of the language. Once we understand how they work, we can use them to construct more complex expressions that get the computer to do what we want it to do. Last off, notice how hello world is written between double quotation marks. Wrapping text in quotation marks indicates that the text is considered a string, which means it's text that will be manipulated by our script. In programming, any text that isn't inside quotation marks is considered part of the code. Now for a bit of trivia. Do you know why we greeted the whole world in our example? Well, printing hello world has been the traditional way to start learning a programming language since way back in the 70s when it was used as the first example in a famous programming book called the C Programming Language. That example looked like this. In Python, the hello world example is just one line. In C, it's 3 lines. In other languages, it could be even more. While learning to write hello world won't teach you the whole language, it gives you a first impression of how functions are used and how a program written in that language looks. All right, now that we've written our first piece of Python code, I think you're ready for something a bit more challenging than hello world. Ready? Let's do it. On the whole, for a program to be useful, it needs to get at least some information from the user. With this data, the program can take actions that are relevant to the user, instead of generic actions like printing hello world. Data can be provided to a computer in a bunch of different ways. For example, on a website, you might input data by entering text into text fields or clicking links. If you're using a mobile application, maybe you'll click on buttons or select preferences from a drop-down menu. In a command line program, you might provide additional data by passing strings as parameters to the program, or you could have the program ask you for data interactively. All these various platforms, programs, and apps process data differently. Some might take the contents of a file as data to be processed, others gather data from other sources and process it in the background. Remember our earlier example when we automated the process of identifying and removing duplicate emails? There, the data provided to the program was the list of emails, which would usually be given in a file that lists the emails one per line. Whichever way your application gets the data, it will need to come from somewhere. For our first examples in this course, we'll just have the data as its own line in our block of code. This is limited, but straightforward. Later in this course, and in upcoming courses, we'll introduce you to better ways of feeding data into your code. For now though, let's see this idea in action in a very simple example. By having the name separate from the call to the print function, we're making the line of code that calls the print function generic, while still personalizing the greeting. If we then wanted to say hello to a different person, we only need to change the name, but the call to the print function will remain the same. Pretty simple, right? Next up, we'll learn a few other easy things that you can get Python to do for you. There's a ton of things that you could do with Python, and you'll learn many of them in this course. But before we dive into complex subjects, let's have some fun with another simple task that you could do with Python. We're going to make Python our calculator. And let's start with something easy. So, 4 plus 5 is 9. 9 times 7 is 63. Minus 1 divided by 4 is minus 0.25. Easy. Repeating or periodic numbers are printed in a longer format. Let's try 1 divided by 3. In math theory, when 1 is divided by 3, the digit 3 repeats forever after the decimal point. Of course, it's hard to display something that repeats forever, so instead we have a representation showing lots of decimal places. Not too hard, right? Let's give the computer something a bit trickier. Let's say we want to divide 2050 by 5, then subtract 32, and then divide the result by 9. To do this, we'll need to use parentheses, just as we do in typical math problems. You can also use Python to get squares, cubes, or any power of n of a number. For example, let's say we want to find out what 2 to the power of 10 is. To get Python to give us the answer, we use the double star operator. If you're starting to worry that this is becoming an algebra course, relax, we're not going to do anything more complex than what we've just seen. And if you're thinking, why would I use Python instead of just a normal calculator? That's a valid question. Experimenting in this way, you get familiar with the language's math capabilities. And in IT jobs, there are many tasks that require you to use math calculations. You might need to count how many times a certain word appears in a text, or work out the average time it takes for an operation to complete, or how much you have to compress an image to fit in certain size constraints. Whatever you need to calculate, writing a script can help you do it faster and with more accuracy. So you need to know what mathematical operations are available to you. Python actually has a lot more advanced numeric capabilities that are used for data analysis, statistics, machine learning, and other scientific applications. We won't get into these in this course, but if you want to learn more about them on your own, there's a wealth of online resources available. Next up, a cheat sheet to help you with programming concepts that we've just covered. And after that, it's time for another quiz. This time with a few small coding exercises. Remember, if something isn't clear, you can re-watch the videos as many times as you need. Ready? You've got this. Now that we've covered some Python coding basics, we'll introduce you to some of the coding tools. Coding tools can help you develop, write, debug, and visualize your code. In this video, we'll cover the basics of code editors and integrated development environments, or IDEs. Code editors are tools used to make writing code easier. With a code editor, you can write, debug, and execute programs in Python. Code editors provide features including syntax highlighting, automatic indentation, error checking, and autocompletion. Overall, code editors help define the code's structure and function. This allows you to write code more efficiently. They also make it easier to understand variables, commands, functions, and loops. VS Code, Jupyter Notebooks, and Colab are some of the code editors we will cover in the next few videos. IDEs have more features than code editors. The difference between a code editor and an IDE is that a code editor is like a text editor. IDEs provide direction in writing code and allow you to see how the code executes. You can think of a code editor like a landline phone. You can dial numbers and make phone calls with it. An IDE is more like a smartphone. You can still make phone calls, but it has additional features that allow you to make video calls, send text messages, browse the internet, and use lots of other applications. An IDE is a software tool that simplifies the process of creating a new software application. An IDE is a software application that provides comprehensive facilities for software development. IDEs always include a code editor. IDEs allow you to develop code more efficiently by bringing multiple tools into one environment. You'll be able to edit, build, test, and package all in one application. They also allow you to program applications more quickly without having to add manual integration and configuration. Coming up, we will cover idle. Idle is an IDE that comes with Python automatically. It's an excellent beginner-level IDE because it's very simple to use. It may not be great for larger projects, but it's excellent for getting to know how to use an IDE. Now, let's dive into some of the code editors and IDEs that you can use as you continue in your Python learning journey. Let's get started with our first coding tool. In this video, you'll learn how to write Python scripts at the command line along with the Python GUI, idle. The command line is used to tell your computer what to do. You can use it to access servers, move files, change directories, and write scripts. In this video, we'll show you how to use the command line and idle on the Linux operating system. If you're using another operating system, you can refer to the reading titled Use the Command Line. Now let's go over the command line on Linux OS. Access the Linux terminal by clicking on it or using Ctrl-Alt-T. This will allow you to check for Python. Type Python. Python comes pre-installed on most Linux systems. If the command is not found, you can install Python by writing sudo apt install python 3. Next, it will ask you for your password. Type your password and press enter. Python version 3 will begin installation. Once installation is complete, you can begin writing Python code from the terminal. Simply type Python 3 to use the interactive mode. Let's try out interactive mode using a print statement. Type print hello world and press enter. You will see the output hello world. To exit interactive mode, we will type exit open parentheses, close parentheses. You can also write Python scripts using Linux with idle. Idle allows you to write Python scripts with ease on your local machine. Idle is an integrated development and learning environment for the Python programming language. Python idle is included with Python installations on Windows and Mac OS. You can download idle using your package manager on Linux. Python idle is an interactive interpreter or file editor that allows you to easily write Python scripts and programs. Idle provides syntax highlighting, code completion, and automatic indentation. To install idle on Linux, type sudo apt install idle. Once installation is complete, type idle to open the interpreter and begin coding. Now we can write a Python file. Once you've completed writing your Python code in the file, go to File, Save As. Give your Python file a name. In this example, we will name our file sum.py. Hit Save. To run the Python code in the file you saved, click Run Module from the menu, or press Enter. Now you know how to use the command line to begin writing Python code. Remember, whichever operating system you're using, you'll be able to run Python from the command line. Using a text editor like idle and running Python from the command line is best for executing and debugging individual scripts or .py files. Next, let's explore some other code editors and IDEs. I'll see you over in the next video. There are many different environments that you can use to write and run code. In this video, you'll learn more about Jupyter Lab and Jupyter Notebooks for writing, running, and debugging Python code. Jupyter Lab and Jupyter Notebooks are part of an open source project called Project Jupyter and are free to use. You can learn more about Project Jupyter at jupyter.org. Jupyter Lab is a web-based interface that allows you to use Jupyter Notebooks to write, run, and debug Python code. Jupyter Lab provides an online environment that allows you to run your code in the cloud. Jupyter Notebook can be used in the web-based interface through Jupyter Lab or on your local machine. Jupyter Notebook allows you to create text-based documents that contain live code blocks. You can write Python programs and scripts using Jupyter Notebooks and see how they execute all in one place. It's a great tool for creating and understanding the code you're writing because you can see your input and output all in one spot. This is what a basic Jupyter Notebook looks like. Next, we will cover how to use Jupyter Notebooks. One of the most popular ways to use Jupyter Notebooks is in the cloud-based environment. you can use this environment by visiting jupyter.org. Once you're at jupyter.org, you can get started. First, click Try, then select Jupyter Lab. To create a new notebook in the lab environment, add a new tab and select Python under Notebook. A new notebook will open up, and you can start writing and running Python code. Let's give it a try. You will write your code in the cell with the blue border. Let's use a print statement. Type print hello world in the cell. Next, we will run the code in the cell. To do this, we'll use the Run button located at the top of the toolbar. Click on Run, and your cell will execute. Your output should be hello world. You can save your Jupyter Notebook by using the Save button that's also located in the top toolbar. Click Save and give your notebook file a name. For this example, I will name my file hello.ipynb. Also, if you would like to download your notebook, you can do that using the File menu located in the top left-hand corner. You can also use Jupyter Lab and Jupyter Notebooks on your local machine. You can do this by using the pip command from the Python terminal command line. To install Jupyter Lab, type pip install Jupyter Lab at the command line. Once it's installed, you can launch it by typing Jupyter-lab. To install Jupyter Notebooks, type pip install notebook at the command line. Once it's installed, you can launch it by typing Jupyter Notebook. Jupyter Lab and Jupyter Notebooks are great resources for writing Python code. To note, notebooks can also be shared and saved easily using email, GitHub, and Jupyter Notebook Viewer. There are also tons of resources on Jupyter Notebooks out there, so if you need more support, the Jupyter website is a great resource to dive deeper into. In the next video, we will go over Colab. This is a coding tool that is very similar to Jupyter Notebooks. Head over to the next video to learn more. Recently, we covered how to use Jupyter Notebooks. In this video, we will go over Colab notebooks. Colab notebooks are Jupyter notebooks that are hosted by Google's Colaboratory. In Colab, you can write and run Python code. In this video, you will learn more about how to use Colab and its features. Colab is a web-based platform that allows you to write and run Python code really quickly in Google Drive. It's free and ready to use with zero configuration required. You can simply visit colab.sandbox.google.com or search Google Colab to get started. Colab provides all of the functionality that Python offers. The cells within Colab can include code, text, and images. The code cells include executable code and rich text, which makes it easy to write and run code. Colab also makes it easy to include Markdown in your notebooks. This is a great feature for sharing notebooks because you can add headings, paragraphs, lists, mathematical formulas, and more. You can install Python packages using the pip command within the code cell. Colab notebooks can easily be shared with other collaborators too. Now let's go over how to use Colab. First, open Google Colab. Again, you can do this by visiting colab.sandbox.google.com. Go to File and click on New Notebook. Now you can begin writing your Python code. In the code cell, let's write a print statement that outputs your name. To run your code and see its execution, use the Run button to the left of the code cell. You can also give your coding project a name. At the top, you can change untitled.ipynb to something like name.ipynb. This will make it easier to find your code in the future. The great thing about Colab is that it automatically stores your notebooks in Google Drive. To find your notebooks, you can simply visit your Google Drive, type in Colab Notebooks in the search bar, and open up the folder titled Colab Notebooks. Here you will see all of the notebooks you've created. And that's how you use Colab. Pretty simple, right? I'm sure by now you're getting the hang of using these code editors. Let's move on to our final one, VS Code. I'll see you in the next video. Now that you're familiar with a few different coding tools, let's take a look at VS Code. VS Code is an open source code editor that includes developer tooling. It's similar to Jupyter Notebooks and Colab, but it includes more features. VS Code provides built-in support with IntelliSense code completion, an interactive debugger, and other build and scripting tools. VS Code has a simple layout that makes it easy to learn and use. Its intuitive features make it a great choice for coding in Python. To use VS Code for Python, you will need to have Python 3, VS Code, and the VS Code Python extension installed. In this video, we're going to show you how to do that. You can use VS Code on Windows, Mac, and Linux operating systems. For this video, we'll be using the Linux operating system. If you're using another operating system, we have provided a reading on using VS Code with the other operating systems that you could take a look at later on. Now let's get started. We'll start by opening a terminal window. Type the following command, Python 3 -- version. If Python 3 is installed, the output will show the Python version that is installed on your computer. An example of what that output would look like is Python 3.10.12. If it is not installed, the output will return command not found. This means you will need to start by installing Python 3. To do this, go to your terminal. At the command line, you will type sudo apt install python 3 and press enter. It will prompt you to enter your password. Enter your password and it will begin installing. As Python 3 is installing, it may prompt you to continue by asking, do you want to continue? Yes/no. Select yes and press enter. Now Python 3 is installed and ready to go. Let's move on to VS Code. You can download VS Code at code.visualstudio.com/download. Here we're going to download the version that is compatible with Linux. Let's select the .deb version of VS Code. We will give it a second to finish downloading. Next, we're going to go back to the terminal. We will navigate to the Downloads folder. We will do this by typing cd downloads /. Then we'll use the ls command. This will list the Debian file we just downloaded. The name of the file you just downloaded will appear. Next, you will type sudo dpkg-i and the name of the file listed. Once that command is executed, Visual Studio Code is installed. To open up Visual Studio Code, we type code at the command line. And Visual Studio Code will open right up for us. The final step is setting up Python in VS Code. To do this, we will browse for extensions. To view extensions in VS Code, we will type Ctrl-Shift-X. This will show you a list of the most popular VS Code extensions on the VS Code Marketplace. You can search for Python using the search bar and click Install. Once it's done installing, it will give you the option to get started with Python development. We'll jump right in by selecting Create Python File. This will open up the code editor. Let's test it out with a simple statement. We're going to type print hello world into the new workspace. Next, click on Run to run the code. You will be prompted to name and save your file. Give your Python file a name and click Save. In this example, we will give our file the name helloworld.py. Your code will run and you will see its output here. Great job! Now, to summarize, VS Code is an extremely robust source code editor. It uses IntelliSense technology, which provides syntax highlighting and autocomplete for coding. VS Code allows you to debug right in the editor with its interactive console. Overall, VS Code is extremely interactive and customizable. There's also a large library of extensions that are easily integrated. Great job! That was a lot to cover. Feel free to review these videos as many times as you need to. And remember, one of the best ways to figure out which tools work best for you are to explore all the features they have to offer and practice using them. Hi there! Welcome back. And well done for completing your first graded assessment. You're doing a great job making it this far. Chances are, some topics we've covered may have been a little tricky at times, especially if you're completely new to programming. Don't worry if something wasn't obvious right away. We went through a lot of new concepts and it might take several passes until you feel comfortable with them. And that's totally normal. We all went through it when we were learning how to code. In the previous module, we explored some basic concepts like programming and automation. We called out that each programming language has a specific syntax, which we need to learn so we can tell the computer what to do. We then got a sneak preview of some of the things we could do with Python. Up next, we'll dive deeper into some basic building blocks of Python syntax. Things like variables, expressions, functions, and conditional blocks. At first glance, these pieces may seem pretty simple, but when we start to combine them, they become a lot more powerful. Understanding a programming language's syntax isn't too different from learning a spoken language. For example, the best way to learn Spanish is to visit a Spanish-speaking country. Immerse yourself in the culture, listen to the people, then figure out how to arrange the words to form a sentence that another speaker can understand. The same is true for programming. When you immerse yourself in Python programming, you'll learn how to formulate statements of code that the computer can understand. This is called syntax. Okay, so as you go through the next few videos, keep in mind that our main goal is to learn the language's syntax. So we'll focus on how to tell our computer what to do, not on how to get it to do complicated tasks. Like before, we'll run through some simple exercises to help you see the concepts in action. And as you pick up the new skills and get to grips with different tools, we'll start to write more advanced scripts that tackle more challenging problems. Again, if at any point you feel confused or that something just isn't clear, remember, you can watch the videos and take the practice quizzes as many times as you need. The key to getting good at programming is practice. Practice and practice. You have to keep working your programming muscles in order to get strong, just like building muscles in the gym. Train hard, train regularly, and you'll be tackling more weighty coding problems in no time. All right, ready to jump back in? In the next video, we're going to learn all about data types. Let's get started. In earlier videos, we called out that text written between quotes in Python is called a string. In programming terminology, a string is known as a data type. Whether it's a mobile game or a script used to automatically create user accounts, most programs need to manipulate some kind of data. And that data can come in a lot of different forms, or, like we call them, data types. A string is only one kind of data type found in Python. There's a bunch of others, like an integer, which represents whole numbers without a fraction, like 1, and float, which represents real numbers, or in other words, a number with a fractional part, like 2.5. Generally, your computer doesn't know how to mix different data types. For example, adding two integers together makes perfect sense to computers, like this. Adding together two strings also makes sense. We just end up with a longer string that contains the two, like so. But your computer doesn't know how to add an integer and a string. If you tell it to mix these two different data types, your computer isn't going to know what to do and will raise an error. Check it out. Oh no, our first error! But don't panic. Errors are a common part of programming, and you'll probably have to deal with them a lot. The trick is to think of errors as little clues from your computer to help you improve your programming skills. Read the errors carefully, understand what they're telling you, and then use that new knowledge to help you fix the mistake. In this example, the last line of the error message shows us that we've encountered something called a type error. When we get a bit of explanatory text that tells us that the plus sign can't be used between an int type and an str type, which are short names for integer and string, thinking about what we've already learned about strings, integers, and mixing data types, can you guess what the error is trying to tell us? The message unsupported operand type tells us that we can't add the integer 7 and the string 8 because they're different data types. But what if you didn't have an instructor to helpfully point that out? How would you know? You'd need to use your research skills and the resources we called out earlier in the course to do some investigating. For example, you could look for information about the error by pasting the type error message into the search bar of your favorite search engine. This is a common trick used by almost everyone learning to code, and even by experienced developers. You'll usually find that other people on the internet have reported similar errors and solved them too. Back to our example. Maybe you're thinking, aren't we adding two numbers here? Looks a bit like it, right? Well, look carefully and remember that anything wrapped in quotation marks is considered a string in Python. So 8 is a string here, while 7 is an integer. To the computer, adding 7 plus 8 is just as strange as adding 7 plus a is to us. And 7 plus a equals no sense at all. It might be helpful to think about data types in terms of information they can represent. For example, the name of a file would be represented as a string data type, while the size of that file might be an integer data type. If you're ever not 100% sure what data type a certain value is, Python gives you a handy way to find out. You can use the type function to have the computer tell you the type. This might come in handy when dealing with code that someone else wrote and you're not sure what data type it's using. For example, Pretty neat, right? This tells us that A belongs to str class, which, like we said earlier, is short for string. The number 2 belongs to the int class, which is short for integer, and 2.5 belongs to the float class. We'll talk more about what we mean by class later in the course. For now, you can just use it as a synonym for data type. So now you know 3 very common data types in Python. There are plenty of others you'll be using soon, but don't worry about them at the moment. As we continue through the course, we'll come across more data types and learn how to interact with each of them. For now, just remember, mixing your data types will get your computer, well, all mixed up. So keep your strings with your strings, your integers with your integers, and your floats with your floats, and you shouldn't get in too much of a tangle. In an earlier video, we saw how we can't use the plus operator between an integer and a string because they're different data types. But what happens when we try to operate with an integer and a float instead? Let's find out. Woohoo! Error-free! Python has no problem performing this operation. But what's up with that? Aren't integer and a float 2 different data types? They sure are, but there's a lot happening under the hood here. Behind the scenes, the computer is busy automatically converting our integer 7 into a float 7. This lets Python then add together the values to return a result that is also a float. We call this process implicit conversion. The interpreter automatically converts one data type into another. We've called this out before, but it's worth highlighting again that Python operations aren't just restricted to numbers. You can also use the plus operator to add together strings. This lets you do things like create sentences from individual words. Just don't forget to add spaces to each word, otherwise the computer will run them all together. So, what if you really want to combine a string and a number? Is it possible? It sure is, but only with an explicit conversion. In Python, to convert between one data type and another, we call a function with the name of the type we're converting to. Let's see how this works. Now things are getting a little bit more complex. Let's take a moment to unpack this to make sure it all makes sense. In this script, we're first calculating the area of a triangle, and when printing it, we're adding it to a string. To do this, we need to call the str function to convert a number into a string. Let's execute it and check out what happens. Our number got converted to a string and printed together with the message. Woohoo! We've learned a little bit about variables, values, expressions, and conversions. Next up, we've got a practice quiz to help you solidify your knowledge. As always, take your time and review the content if you need. You've totally got this. I'll see you in the next video once you're finished. Woohoo! You made it through another quiz! You are doing awesomely. Keep it up. So far, we've been looking at variables, expressions, and operations, which are the smallest components of scripts. Up next, we're going to look at functions, which are another crucial programming building block. We've come across a few Python functions in our example so far. The print function that writes text on the screen, the type function which tells us the type of a certain value, and the str function which converts a number into a string. All those functions come as a part of the language, and we'll look into a bunch of other built-in Python functions throughout this course. But now, we're going to see how to define our own functions to tell the computer to do things that the language's built-in functions don't. Let's start with a simple example. In this piece of code, we're defining a function. Our function takes a parameter. Here, that parameter is name, and prints a greeting for that name. This snippet is small, but it already shows a lot of important points about how we define functions in Python. Let's go through this step by step. To define a function, we use the def keyword. The name of the function is what comes after the keyword. In this example, the function's name is greeting. So to call the function later in the script, we'll use the word greeting. After the name, we have the parameters of the function, which are written between parentheses. In this example, we only have one parameter, name, followed by a colon at the end of the line. After the colon, we have the body of the function. That's where we state what we want our function to do. Note how the body is indented to the right. This is a key characteristic of Python, and we'll come across it a bunch. For now, just keep in mind that the body of the function must be to the right of the definition. In this example, the body contains just one line that calls the print function. Looks simple, right? But creating functions can actually be super powerful. The body of a function can have as many lines as we want it to, and do all sorts of fun stuff. We'll find out exactly what in later videos. But for now, let's execute our function and see what happens. That's nice, but it's not too interesting yet. Let's make it do a little more. Our function now receives 2 parameters instead of 1, name and department, and it writes 2 separate messages. Again, notice the indentation. We can add as many lines as we'd like to the body of the function, but each line must be indented the same number of spaces to the right. In this example, we're using 4 spaces. We could use 2 or 8 or any other number as long as they're all consistent. Let's try calling our new and improved greeting function. Nice. That's more useful. And we're only just scratching the surface of what we can do with functions. Remember that these are just simple examples, but a function can do a lot more than just print messages. In this course, and throughout the upcoming courses, we'll explore a bunch of other tasks that we can do with Python, and usually we'll write them inside functions. How are you feeling so far? These new concepts are coming fast and furious now. Are you starting to get to grips with it all? If so, awesome. And if some things are still a little fuzzy, now is a great moment to go back and review everything we've covered up till now. Once you're feeling good, meet me on over in the next video. We've seen how we can pass values into a function as parameters by passing values like the name or department in the example earlier. But what about getting values out of a function? This is where the concept of return values comes to play. The work that functions do can produce new results. Sure, we can print the results on the screen, but what if we wanted to use those results later in our script, or didn't want to print them at all? We can do this by returning values from the functions we define ourselves. Let's go back to calculating the area of a triangle. Do you remember our triangle example from our earlier exercise? The area of the triangle is calculated as base times height divided by 2. Imagine we need to calculate this value several times in our code. It would be useful to have a function that does this for us. Check out how this would look. We use the keyword return to tell Python that this is the return value of a function. When we call the function, we store that value in a variable. Let's say we have the 2 triangles and we want to add up the sum of both areas. Here's what we would do. First, we calculate the 2 areas separately. Then, we add the sum of both areas together. Finally, we print the result, converting it to a string. As you can see in this example, the area triangle function returns a value, which is, not surprisingly, the area of the triangle. We store that value in a different variable for each call to the function. In this case, area A and area B. And then we operate with those values, adding them into the variable called sum and only printing this final result. This shows the power of the return statement. It allows us to combine calls to functions into more complex operations, which makes your code more reusable. Return statements in Python are even more interesting because we can use them to return more than one value. Let's say you have a duration of time in seconds, and you want to convert that to the equivalent number of hours, minutes, and seconds. Here's how to do that in Python. Did you spot the new operator in this function? That double slash operator is called floor division. A floor division divides a number and takes the integer part of the division as the result. For example, 5//2 is 2 instead of 2.5. In our example, the first operation is calculating how many hours are in the given amount of seconds, while the second works out how many minutes are left once we subtract the hours, and then how many seconds remain after subtracting the minutes. We end up with 3 numbers as our result, so the function returns all 3 of them. Let's see what this looks like when we're calling a function. Because we know that the function returns 3 values, we assign the result of the function to 3 different variables. There's one last thing we should call out about returning values. It is possible to return nothing, and that's perfectly okay. Let's look at an example from an earlier video. Here, the function just printed a message and didn't return anything. What do you think would happen if we try to assign the value of this function to a variable? Let's try it out and see. Here, when we called the function, it printed a message, just like we expected. We stored the return value in the result variable, but there was no return statement in the function, so the value of result is none. None is a very special data type in Python, used to indicate that things are empty, or that they return nothing. Wow, that was a lot to learn about functions and the return values. Remember that the key to getting this right is to practice writing the code you just learned as many times as you need. Functions and return values can be tricky concepts to master, but they let us do a bunch of cool stuff. So put the time and effort in to learn it for some really valuable returns. As we've called out before, functions are powerful because you can create your own. You can use them to organize the code in your scripts into logical blocks, which makes the code you write easier to use and reuse. Check out this example. This script uses the len function, which returns the length of its string. In this example, the script then uses that length to calculate a number, which we're calling the lucky number here. And finally, it prints a message with the name and the number. Each time we want to perform the calculation, we change the values of the variables and write the formula, then print a greeting followed by the lucky number. See how there are exactly 2 lines that are the same in the first and second part of the code? When you find code duplication in your scripts, it's a good idea to check if you can clean things up a bit by using a function. How about we rewrite this code, creating a function to group all the duplicated code into just one line? The updated script gives us the exact same result as the original one, but it looks a lot cleaner. First, we've defined a function called luckyNumber, which carries out our calculation and prints it for us. Then we call the function twice, once with each name. Since we've grouped the calculation and print statements into a function, our code is not only easier to read, but it's also now reusable. We can execute the code inside the luckyNumber function as many times as we need it by just calling it with a different name. So we don't have to write it out and again for each new name. Does that make sense? Hopefully these examples have helped explain how functions are used and defined, and also demonstrated how useful they can be. Did you notice that we're feeding information into our functions through their parameters? This is one of the many ways that we can input data into our code. The values for those parameters may come from different places, like a file on our computer or through a form on a website, but that doesn't impact our code. The result of the function is still the same no matter where the parameters come from. Functions are your friends. They can help clean up your code and do math so you don't have to. You'll be using them a lot, both in this course and in your programming life. So get ready to get real friendly with functions. So far, we've looked into how the Python syntax is used for variables, expressions, and defining and using functions. There's a lot more syntax to come, but before we dive into that, let's talk a bit about a different side of programming: style. On the whole, having good or bad style when you write code doesn't make much difference between a script succeeding or crashing, but it can make a big difference for the people who use it and contribute to it. Poor programming style can make life difficult for the IT specialists or system administrators who have to read the script after it's written or make changes to it so it works with a new system. Bad style can even give the script's author a headache if it's been a while since they've wrote it. Imagine having to rewrite your own code because it's too messy to understand. Yikes! On the flip side, good style can make a script look almost like natural human language. It can make the script's intent and construction immediately clear to the reader. Good style makes life easier for people who have to maintain the code and helps them understand what it does and how it does it. It can also reduce errors, since it makes updating the code easier and more straightforward. And most importantly, good style makes you look cool, right? So, we agree, our code should be stylish. But what makes the style of a piece of code good or bad? Although there are no hard and fast rules that apply to every programming language and situation, keeping a few principles in mind will go a long way to creating good, well-styled code. First off, you want your code to be as self-documenting as possible. Self-documenting code is written in a way that's readable and doesn't conceal its intent. This principle can be applied to all aspects of writing code, from picking your variable names to writing clear, concise expressions. Take this code snippet, for example. It's hard to determine the purpose of this code by just looking at it. The names of the variables don't give the reader much information, and although you can likely work out the result of the calculation, there are no clues to what that result might be used for. In programming lingo, when we rewrite code to be more self-documenting, we call this process refactoring. So how would it look if we refactored this code? With this refactored code, the intent should now be more clear. The names of the variables and the function reflect their purpose, which helps the reader understand the code more quickly. You should always aim for your code to be self-documenting. But even then, sometimes you may need to use a particularly tricky bit of code in your script. When good naming and clean organization can't make the code clear, you can add a bit of explanatory text to the code. You do this by adding what we call a comment. In Python, comments are indicated by the hash character. When your computer sees a hash character, it understands that it should ignore everything that comes after that character on that line. Check out how this looks. Using comments lets you explain why a function does something a certain way. It also allows you to leave notes to your future self or other programmers to remind you of what needs to be improved and why. Obviously, it's much easier to read your own code than someone else's, but in my job, I work on code that was written by lots of different people, and everybody designs things a little differently. This is why it's so important to comment and document your code well. More often than not, your code will eventually be used by someone other than you. So be a good neighbor. Use a style guide to structure your code in a way that's readable by others, or by you in 6 months when you've forgotten why you wrote that code in the first place. In upcoming exercises in this course, we'll use comments to let you know what you need to do with the code, and you can always write as many extra comments as you need. Coming up, a quiz to consolidate your newly acquired knowledge about functions. Don't worry, you've got this. We've seen a few arithmetic expressions so far, like addition, subtraction, and division. Remember when we turned Python into a calculator? Well, Python can also compare values. This lets us check whether something is smaller than, equal to, or bigger than something else. This allows us to take the result of our expressions and use them to make decisions. Check out these 3 examples. In the first example, 10 is greater than 1, so the value true is printed as a result. True is a value that belongs to another data type called a Boolean. Booleans represent one of 2 possible states, either true or false. Every time you compare things in Python, the result is a Boolean of the appropriate value. In the second example, we can see our very first equality operator, which is formed by putting 2 equal signs together. We use this operator to test whether 2 things are equal to each other. In this example, the string cat is not equal to the string dog, so the Boolean that's printed is false. In our third example, we're doing the opposite comparison. By pairing an exclamation mark and an equals sign, we're using the not equals operator, which is the negated form of the equality operator. In this particular line of code, the operator checks that 1 isn't equal to 2. We called out before that the plus operator doesn't work between integers and strings. What do you think will happen if we try to compare an integer and a string? Let's find out by seeing if the number 1 is smaller than the string 1. Womp womp womp. We get a type error. That's the same error we got before. This happens because Python doesn't know how to check if a number is smaller than a string. And what about the equality operator? In this case, the interpreter has no problem telling us that the integer 1 and the string 1 aren't the same. So what gives? Basically, although they may seem similar to us because they both contain the same number, it's clear to the computer that one is a number and the other is a string. For the computer, it's obvious that they are completely different entities. On top of the comparison and equality operators, Python also has a set of logical operators. These operators allow you to connect multiple statements together and perform more complex comparisons. In Python, the logical operators are the words and, or, and not. Let's look at some examples. To evaluate as true, the AND operator would need both expressions to be true at the same time. Here we're comparing strings, and the bigger and smaller operators refer to alphabetical order. Yellow comes after cyan, but brown doesn't come after magenta. So this means that the first statement is true, but the second one isn't, which makes the result of the whole expression false. If we use the OR operator instead, the expression will be true if either of the expressions are true, and false only when both expressions are false. Let's try it out. 25 is definitely not bigger than 50, but 1 is different than 2. So in the end, the whole expression is true. Last up, the NOT operator inverts the value of the expression that's in front of it. If the expression is true, it becomes false. If it's false, it becomes true, just like this. Logical operators are important because they help us write more complex expressions. We'll see this in action in the next few videos. If this is the first time you've come across these operators, it might seem like there's a lot to remember. But don't worry, you'll learn most of them very quickly just by practicing. And in the next reading, we have a cheat sheet that lists all the operators available and what each one does. It's a handy resource you're sure to find useful when writing your own scripts. Now that we're armed with knowledge of Python's expressions, comparators, and variables, we can dive right into how to use them in our scripts to perform different actions based on their values. The ability of a program to alter its execution sequence is called branching, and it's a key component in making your scripts useful. You probably use the idea of branching a bunch in your everyday life. For example, if it's before noon, you might greet someone by saying good morning instead of good afternoon or good evening. If it's raining outside, you might choose to take an umbrella. If it's cold, you probably wear a jacket. In your scripts, you can instruct your computer to make decisions based on inputs too. Let's take a look at an IT-focused example. In many companies, new employees can choose the username they'll use to access the company's systems. And usually the chosen username needs to fit with a given set of guidelines. Companies can set different criteria for what a valid username looks like. For now, let's assume that at your company, a valid username has to have at least 3 characters. You've been tasked with writing a program that will tell the user if their choice is valid or not. To do that, you could write a function like this. This function checks whether the length of the username is smaller than 3. If it is, the function prints a message saying that the username is invalid. Look closely at how the if statement is written. We write the keyword if followed by the condition that we want to check for, and then followed by a colon. After that comes the body of the if block, which is indented further to the right. You may notice that there are some similarities between how an if block and a function are defined. The keyword, either def or if, indicates the start of a special block. At the end of the first line, we use a colon, and then the body of the function, or the if block, is indented to the right. But there's also an important difference between how an if block and a function are defined. The body of the if block will only execute when the condition evaluates to true. Otherwise, it's skipped. Of course, you can do a lot more things inside the body of the if block than just printing stuff. As we expand our programming abilities, we'll learn how to do things like shorten text that's too long, delete a file if it exists, start a service if it's not running, and a bunch more. If your code is inside a function, you could also choose to return a value depending on whether a certain condition is met. Can you imagine how that would look? By now, you know how to define functions, and inside those functions, you can now make your program do something only when certain conditions are met. Ready to branch out and make our branches even more interesting with else statements? Then hop on over to the next video, or else you'll miss out. The if statement is already a pretty useful construct, but we can extend it to make it even more powerful. Think about the username example from the last video. What if we also wanted to print a message when the username was valid? Here, we've included an else statement to achieve this. The program can now go in one of 2 directions depending on the length of the username. If it's not long enough, we get a message indicating that the username is invalid. But if the program verifies that the username is long enough, it will print a message saying it is valid. Pay attention to how the else statement is written. It uses the else keyword followed by a colon to indicate the beginning of the else block. Once again, the body of the block is further indented to the right. As we've called out before, these blocks can contain multiple lines and do more than just print messages. They can do calculations, modify values, return values, and a lot more. And remember that you can choose to use as many or as few spaces as you want for the indentation. But you always need to indent, and you always need to use the same number of spaces. The else statement is very useful, but we don't always need it. Say we want to have a function that checks if a value is even or odd. We could do that with a piece of code like this. Here we're using a new operator, so let's first explain that. The modulo operator is represented by the percentage sign and returns the remainder of the integer division between two numbers. The integer division is an operation between integers that yields two results, which are both integers, the quotient and the remainder. So if we do an integer division between 5 and 2, the quotient is 2 and the remainder is 1. If we do an integer division between 11 and 3, the quotient is 3 and the remainder is 2. Even numbers are all multiples of 2, which means the remainder of the integer division between an even number and 2 is always going to be 0. In this function, we're using this principle to decide whether a number is even or not. So, how come we have these two return statements, one below the other, without an else statement? The trick is that when a return statement is executed, the function exits, so that the code that follows doesn't get executed. This means that if the number is even, the computer will reach the return true statement and exit the function. Anything that comes after that will only be executed if the condition in the if statement was false. In other words, once the function reaches the return false line, we know for sure that the if condition was false, which means the number was odd. At first, you might feel more comfortable including the else statement even if it's not needed, and that's totally okay. It's important to know that both ways of writing this are correct. And remember that this technique can only be used when you're returning a value inside the if statement. To recap, the if statement allows us to branch the execution based on a specific condition being true. The else statement lets us set a piece of code to run only when the condition of the if statement was false. If you return a value inside an if block, then the code after the block will only be executed if the condition was false. All makes sense? If all these ifs and elses are starting to get a little confusing, that's okay. There's a lot to soak up here, and the best way to do that is, yeah, you guessed it, practice. So review the content and practice on your own as much as you need. Once you're done, meet me over in the next video. The if and else blocks allow us to branch execution depending on whether a condition is true or false. But what if there are more conditions to take into account? This is where the elif statement, which is short for else if, comes into play. But before we jump into how to use it, let's take a look at why we need it in the first place. Let's go back to our trusty username validation example. Now, what if your company also had a rule that usernames longer than 15 characters aren't allowed? How could we let the user know if their chosen username was too long? We could do it like this. In this case, we're adding an extra if block inside the else block. This works, but the way the code is nested makes it kind of hard to read. To avoid unnecessary nesting and make the code clearer, Python gives us the elif keyword, which lets us handle more than 2 comparison cases. Take a look. The elif statement looks very similar to the if statement. It's followed by a condition and a colon, and a block of code indented to the right that forms the body. The condition must be true for the body of the elif block to be executed. The main difference between elif and if statements is we can only write an elif block as a companion to an if block. That's because the condition of the elif statement will only be checked if the condition of the if statement wasn't true. So in this example, the program first checks whether the username is less than 3 characters long and prints a message if that's the case. If the username has at least 3 characters, the program then checks if it's longer than 15 characters. If it is, we get a message to tell us that. Finally, if none of the above conditions were met, the program prints a message indicating that the username is valid. There's no limit to how many conditions we can add, and it's easy to include new ones. For example, say the company decided that the username shouldn't include numbers. We could easily add an extra elif condition to check for this. Cool, right? You now know how to compare things and use those comparisons for your if, elif, and else statements, and you're using all of them inside functions. Using branching to determine your program's flow opens up a whole new realm of possibilities in your scripts. You can use comparisons to pick between executing different pieces of code, which makes your script pretty flexible. Branching also helps you do all kinds of practical things, like only backing up files with a certain extension, or only allowing login access to a server during certain times of the day. Anytime your program needs to make a decision, you can specify its behavior with a branching statement. Are you starting to notice tasks in your day-to-day that could be made more efficient with scripting? There's so many possibilities, and we're only just getting started with all the cool stuff programming can help you do. Wow, we've covered a lot in these last few videos. Remembering all these concepts can take some time, and the best way to learn them is to use them. So we've put together a cheat sheet for you in the next reading. You'll find all these operators and branching blocks listed there in one handy resource. It's super useful when you need a quick refresher. So no skipping the reading. Hi there, and welcome back. Before we dive back in, I want to first say well done. We've learned a lot of new skills in a short amount of time and tackled some pretty tricky concepts. None of this stuff is easy, and you're doing so great. So we've got some fun concepts lined up for the next few videos. So far, we've seen how to organize our code and functions. We've also made our code branch into different paths depending on certain conditions. In this module, we'll learn how to get computers to do repetitive tasks, which is another cornerstone of programming. As we've called out before, computers are great at repeating the same task over and over. They never get bored or make a mistake. You could ask a computer to do the same calculation 1,000 times and the first result would be just as accurate as the last, which isn't something we can say about us humans. Have you ever tried to do something 1,000 times in a row? It'd be enough to drive you loopy. Which is why in this course we're going to learn how to leave the loops up to the computer. The ability to accurately perform repetitive tasks and never get tired is why computers are so great for automation. The automated task could be anything, like copying files to a bunch of computers on a network, sending personalized emails to a list of users, or verifying that a process is still running. It doesn't matter how complex the task is, your computer will do it as many times as you tell it to, which leaves you time for more interesting things, like planning future hardware needs or managing software rollouts. In the next few videos, we'll explore 3 techniques for automating repetitive tasks. These are while loops, for loops, and recursion. Each of these techniques are used to tell the computer to repeat a task, but each takes a slightly different approach. We're going to learn how to write the code for each and how to know when to use one technique instead of the others. So, are you ready? Let's get started. First off, we're going to talk about while loops. While loops instruct your computer to continuously execute your code based on the value of a condition. This works in a similar way to branching if statements. The difference here is that the body of the block can be executed multiple times instead of just once. Check out this program. Can you guess what it does? Before we execute it to find out, let's go through it together line by line. In the first line, we're assigning the value of 0 to the variable x. We call this action initializing, to give an initial value to a variable. In the line after that, we're starting the while loop. We're setting a condition for this loop that x needs to be smaller than 5. Right now, we know that x is 0, since we've just initialized it, so this condition is currently true. On the next 2 lines, we have a block that's indented to the right. Here, we can use what we learned about functions and conditionals to identify that this is the while loop's body. There are 2 lines in the body of the loop. In the first line, we print a message followed by the current value of x. In the second line, we increment the value of x. We do this by adding 1 to its current value and assigning it back to x. So, after the first execution of the body of the loop, x will be 1 instead of 0. Because this is a loop, the computer doesn't just continue executing with the next line in the script. Instead, it loops back around to reevaluate the condition for the while loop. And because 1 here is still smaller than 5, it executes the body of the loop again. It then prints the message and once more increments x by 1. So the x is now 2. The computer will keep doing this until the condition isn't true anymore. In this example, the condition will be false when x is no longer smaller than 5. Once the condition is false, the loop finishes and the next line is executed. And finally, the last line of our code prints the last value of x. So now that this code makes a bit more sense, what do you think will happen when we execute it? Ready to find out? Let's execute the code and see what happens. So we had 5 lines with the message, "not there yet," and then at the end of the script, the value of x was 5. This was a simple example of how a while loop behaves. As we've said before, we're learning the building blocks of programming. Once you know those building blocks, you can combine them to create more complex expressions. As an IT specialist, while loops can be super helpful. You can use them to keep asking for a username if the one provided isn't valid, or maybe try an operation until it succeeds. Knowing how to construct these expressions can help you get your computer to do a whole lot with only a little bit of code. It's pretty powerful stuff we're learning here. Now that you've got an idea of how a while loop works, let's spice it up with another example. In the last video, we saw a very simple example of a while loop. We looked at a basic syntax of the loop and how it works. Let's now apply this knowledge to a similar example, but this time with a while loop inside a function. Can you work out what this function does? In this example, we start out by initializing a variable called x. In this case, we initialize it with the value of 1. Then we enter our while loop, which checks to see if the value inside of the x variable is less than the parameter n that the function received. If that comparison evaluates to true, then the code inside the while block is executed. Say we pass a value of 5 as a parameter to this function. In the first pass through the loop, x is always equal to 1, so the comparison 1 smaller than or equal to 5 would be true, and we'd then enter the body of the loop. In the body, we first print a message indicating that the current attempt number, and then we increase the value of x by 1. To increment the number, we're using a slightly different expression than before. X plus equal 1 is a shorthand version of x equals x plus 1. You can use either expression since they both mean the same thing. The process continues until the result of the comparison isn't true anymore, which happens when x is bigger than n. In our current example, this would be when the value of x is 6. Let's see it in action. In these past examples, we've used the simple conditions of a number being smaller or equal than another number. These are common conditions, but they're by no means the only conditions you can have in a while loop. It's common, for example, to call a separate function that evaluates the condition, like this. In this case, there's a lot of code hidden behind functions, and it's doing stuff we don't see. There's a getUsername function that asks the user for a username, and a validUsername function that validates that username. And all this is happening in just a handful of characters. As you can see, you can pack a lot of punch into just a short line of code. In this case, the body of the while loop will be executed until the user enters a valid username. The important thing to remember is that the condition used by the while loop needs to evaluate to true or false. It doesn't matter if this is done by using comparison operators or calling additional functions. The conditions used in while loops can also become more complex if we use the logical operators that we encountered when looking into branching, and, or, and not. This lets us combine the values of several expressions to get the result we want. Okay, we've now covered what a while loop is and learned its syntax and basic behavior. Some of this stuff can be a bit tricky, and you're doing great. Keep sticking with it. Next, we're going to do a rundown of some of the most common pitfalls that you may come across when writing your own loops. Head on over to the next video to get started. You may remember by now that while loops use a condition to check when to exit. The body of the while loop needs to make sure that the condition being checked will change. If it doesn't change, the loop may never finish, and we get what's called an infinite loop, a loop that keeps executing and never stops. Check out this example. It uses the modulo operator that we saw a while back. This cycle will finish for positive and negative values of x. But what would happen if x was 0? the remainder of 0 divided by 2 is 0, so the condition would be true. And the result of dividing 0 by 2 would also be 0, so the value of x wouldn't change. This loop would go on forever, and so we'd get an infinite loop. If our code was called with x having the value of 0, the computer would just waste resources doing a division that would never lead to the loop stopping. The program would be stuck in an infinite loop, circling back around endlessly. And we don't want that. All that looping might make your computer dizzy. To avoid this, we need to think about what needs to happen for a loop to be successful. In this example, we said that x needs to be different than 0. So we could nest this while loop inside an if statement, just like this. With this approach, the while loop is executed only when x is not 0. Alternatively, we could add the condition directly to the loop using a logical operator, like in this example. This makes sure we only enter the body of the loop for values of x that are both different than 0 and even. Talking about infinite loop reminds me of one of the first times I used while loops myself. I wrote a script that emailed me as a way of verifying that the code worked. And while some condition was true, I forgot to exit the loop. Turns out those emails get sent faster than once per second. As you can imagine, I got about 500 emails before I realized what was going on. Infinitely grateful for that little lesson. When you're done laughing at my story, remember, when you're writing loops, it's a good idea to take a moment to consider the different values a variable can take. This helps you make sure your loop won't get stuck. If you see that your program is running forever without finishing, have a second look at your loops to check there's no infinite loop hiding somewhere in the code. While you need to watch out for infinite loops, they're not always a bad thing. Sometimes you actually want your program to execute continuously until some external condition is met. If you've used the ping utility on Linux or macOS system, or ping-t on a Windows system, you've seen an infinite loop in action. This tool will keep sending packets and printing the results to the terminal unless you send it the interrupt signal, usually pressing Ctrl-C. If you were looking at the program's source code, you'd see that it uses an infinite loop to do this, with a block of code with instructions to keep sending the packets forever. One thing to call out is it should always be possible to break the loop by sending a certain signal. In the ping example, that signal is the user pressing Ctrl-C. In other cases, it could be that the user pressed a button on a graphical application, or that another program sent a specific signal, or even that a time limit was reached. In your code, you could have an infinite loop that looks something like this. In Python, we use the break keyword, which you can see here, to signal that the current loop should stop running. We can use it not only to stop infinite loops, but also to stop a loop early if the code has already achieved what's needed. So, quick refresh. How do you avoid the most common pitfalls when writing while loops? First, remember to initialize your variables, and second, check that your loops won't run forever. Wow, all this talk of loops is making me feel a little loopy. I'm gonna have to go and lie down while you do the next practice quiz. Best of luck, and meet me over in the next video when you're done. Okay, how are you doing? If all this talk of loops is starting to make your head spin, remember that there's nothing wrong with looping back around and reviewing what you've learned. It's the quickest way to stop feeling like you're running in circles. All right, feeling good? Great, then we're ready for a different type of loop. In this video, we're going to meet the for loop. A for loop iterates over a sequence of values. A very simple example of a for loop is to iterate over a sequence of numbers, like this. Notice how this structure is kind of similar to the structures we've already seen. The first line indicates the distinguishing keyword. In this case, that's for, and it ends with a colon. The body of the loop is indented to the right, like we saw in the while loop, the if block, and the function definitions. What's different in this case is that we have the keyword in. Also, between the for keyword and in keyword, we have the name of a variable. This variable will take each of the values in the sequence that loop iterates through. So in this example, it'll iterate through a sequence of numbers generated using the range function. There are two important things I want to call out about this range function. First, in Python and a lot of other programming languages, a range of numbers will start with the value 0 by default. Second, the list of numbers generated will be one less than the given value. In the simple example here, x will take the values 0, 1, 2, 3, and 4. Let's check this out. So there we have a very basic for loop. It iterates over a sequence of numbers generated by the range function. When using a for loop, we point the variable defined between for and in this case x, at each element of the sequence. This means on the first iteration, x points at 1, on the second iteration it points at 2, and so on. Whatever code we put in the body of the loop will be executed on each of the values, one value at a time. As we said earlier, the loop's body can do a lot of things with the values it iterates. For example, you could have a function to calculate the square of a number, and then use a for loop to sum the squares of the numbers in a range. Iterating over numbers looks very similar to the while loop examples we showed before. So you may be wondering, why have two loops that look like they do the same thing? Well, the power of the for loop is that we can use it to iterate over a sequence of values of any type, not just a range of numbers. Think all the way back to our very first Python example in this course. Remember our trusty hi friends script? In it, we saw a for loop that iterated over a list of strings. It looked like this. We'll talk a lot more about lists later on, but for now, you only need to know that we can construct lists using square brackets and separate the elements in them with commas. In this example, we're iterating a list of strings, and for each of the strings in the list, we're printing a greeting. The sequence that the for loop iterates over could contain any type of element, not just strings. For example, we could iterate over a list of numbers to calculate the total sum and average. Here's one way of doing this. Here, we're defining a list of values. After that, we're initializing two variables, sum and length, that will update in the body of the for loop. In the for loop, we're iterating over each of the values in the list, adding the current value to the sum of values, and then also adding 1 to length, which calculates how many elements there are in the list. Once we've gone through the whole list, we print out the sum and the average. We'll keep using for loops in our examples every time we want to iterate over the elements of any sequence and operate with them. Some examples of sequences that we can iterate are the files in a directory, the lines in a file, the processes running on a machine, and there's a bunch of others. So as an IT specialist, you'll use for loops to automate tons of stuff. For example, you might use them to copy files to machines, process the contents of files, automatically install software, and a lot more. A few weeks ago, I had to update a lot of files with different values depending on their contents. So I used a for loop in a script to iterate over all the files. Then my script took different actions based on an if condition and updated all of those files for me. It would have taken me forever if I had done this manually file by file. If you're wondering when you should use for loops and when you should use while loops, there's a way to tell. Use for loops when there's a sequence of elements that you want to iterate. Use while loops when you want to repeat an action until a condition changes. And if whatever you're trying to do can be done with either for or while loops, just use whichever one's your favorite. I'm more of a while gal myself, but it's totally your call. Next up, we've put together more examples to help get you more practice with for loops and discover some of the cool things you could do with them. In the last video, we talked about the range function and how it generates a sequence of numbers starting with 0. Sometimes, though, we don't want to start with 0. For these situations, the range function also allows us to specify the first element of the list to generate. We do that by passing 2 parameters to the function instead of 1, like in the next example. Product equals 1 for n in range 1 to 10. Product equals product n print product. In this example, we're calculating the product of all numbers from 1 to 9. For this operation, it's important that we start with 1 and not with 0. If we'd started with 0, the whole product would be 0. Additionally, we can specify a third parameter to change the size of each step. This means that instead of going 1 by 1, we could have a larger difference between the elements. Let's check out this example of when you might want to do something like this. First, we're defining a function that converts a temperature value from Fahrenheit to Celsius. And we're simply using a conversion formula to do that. Then, we have a for loop that starts at 0 and goes up to 100 in steps of 10. Notice that we're using 101 for the upper limit instead of 100. We're doing this because the range never includes the last element, and we want to include 100 in our range. The body of the for loop prints the value in Fahrenheit and the value in Celsius, creating a conversion table. Let's see this in action. That example got you feeling the heat? Don't worry, there's a quick rundown of what we've learned. The range function can receive 1, 2, or 3 parameters. If it receives 1 parameter, it will create a sequence, 1 by 1, from 0 until 1 less than the parameter received. If it receives 2 parameters, it will create a sequence, 1 by 1, from the first parameter until 1 less than the second parameter. Finally, if it receives 3 parameters, it will create a sequence starting from the first number and moving towards the second number, but this time the jumps between the numbers will be the size of the third number. And again, it will stop before the second number. This might sound like a lot to remember, but don't panic. As we've said before, you don't have to try to memorize it all, just keep practicing and it'll soon become second nature. You're doing great getting your head around all these loops. I think you're ready for something a little bit more complex. We're going to explore what happens when you get loops inside of loops. Does that make your head spin? Don't worry, we're about to break it down for you with a couple of examples. Have you ever played dominoes before? There's a bunch of fun games you can play with these tiles. In case you're not familiar, each domino tile has 2 numbers represented by a collection of dots carved on each half of the tile. The numbers go from 0 to 6. Tiles can be rotated so that each combination of numbers is represented only once in a set of domino tiles. In other words, the 2-3 tile is the same as the 3-2 tile, and there's only 1 per set. Now, imagine we wanted to write a program that prints each domino tile in a set. If we take all of the tiles that have 0 on the left, we can print tiles with numbers from 0 to 6 on the right. That should be easy to do with a for loop. But what about tiles that have 1 on the left? Well, we need to skip the 1-0 tile because that one was already printed as 0-1. So, we could print a list of tiles with 1 on the left and numbers from 1 to 6 on the right. When we look at 2, we would need to skip both 0 and 1, and so on. Are you following along? How do you think we'd write the code for this? Turning this into code means that we'd need to write 2 for loops, one inside the other. This is what we call nested for loops. Check out how this looks in Python code. For left in range 7, for right in range left 7, print, we're going to do left bracket plus str left plus pipe plus str right plus close bracket end equals space. And print. In this code, we're using a new parameter that we pass to the print function. This parameter is called end. Normally, once print has taken the content we passed and written it to the screen, then it writes a special character that creates a new line called the new line character. If we want print to write something else instead of the new line character, we use the end parameter, like we see in this example. Notice how the second for loop iterates over a different number of elements each time it's called as the value of left changes. Depending on what you want to achieve with your nested loops, you may want both loops to always go through the same number of elements. Or you might want the second loop to connect to the first one. Let's look at a different example. Let's say you run a local girls' basketball league in your town. You have 4 teams that will play against each other in the league, both at home and away. You've stored the names of the teams in a list, like this. We want to write a script that will output all possible team pairings. For this, the order of the names matters because for each game, the first name will be the home team and the second name is the away team. And of course, what we don't want to do is have a team playing against itself. So, what statement do we need to use to avoid that? To do this, we need to use a conditional that makes sure we only print the pairing when the names are different. Check out what this looks like. For home team in teams, for away team in teams, if home team not equal to away team, print home team versus away team. Success! As you can see, nested loops are super useful for solving certain problems, like pairing teams. What it doesn't solve is the question, who would win in a face-off between dragons and unicorns? If only there were some code for that. Anyway, we've seen that nested loops are a handy tool, but we need to be careful not to just blindly apply them to any problem. Why? Well, because the longer the lists your code needs to iterate through, the longer it takes your computer to complete the task. Let's say your manager asks you to do an operation that will run through a list of 10,000 elements. If the operation takes 1 millisecond per element, the whole loop would take 1 millisecond times 10,000 to complete, which is 10 seconds. Now, imagine we add a nested loop that has to go over the same 10,000 elements. This means that each iteration of the outside loop would do a full iteration of the inside loop, which again would take 10 seconds to go through the whole list. So now the whole iteration takes 10,000 times 10 seconds, which is 100,000 seconds. That's over 27 hours. I have the patience of a gnat, so that would definitely not work for me. This doesn't mean we shouldn't use nested loops. They're a useful tool when solving problems that require them, but we need to be careful of where and how we use them. Throughout this course, and ones coming up, we'll look at a lot of techniques that can help us pick the right tool to use for each type of problem. Up next, we'll look into some common errors that you might come across when writing your for loops and what to do about them. We've now seen how to write for loops, combine them with functions, nest a for loop inside a different loop, and even combine a nested loop with conditionals. Nice job, you're chugging right along. But before we're done with for loops, let's check out some common mistakes you may come across while trying this yourself. As we've called out already, for loops iterate over sequences. The interpreter will refuse to iterate over a single element. As you see here,
for x in 25, print x.
In this example, we're trying to iterate over the number 25. Python prints a type error telling us that integers are not iterable. There are two solutions to this problem, depending on what we're trying to do. If we want to go from 0 to 25, then we use the range function.
So for x in range 25, print x.
But if we're trying to iterate over a list that has 25 as the only element, then it needs to be a list. And that means writing it between square brackets.
For x in list 25, print x.
You might be wondering why you'd ever want to iterate over a list of one element. And that's a good question. Well, this kind of issue usually happens when you have a function with a for loop inside it, which is iterating over the elements of a list received by parameter. Say, for example, you have a function that fixes the permissions of a list of files received by parameter, and you want to call this function to fix the permissions of just one specific file. To do that, you need to pass the file as the single element of a list. Let's check this out with some code we're familiar with, our friendliest of Python examples. Hi, friends. We're going to modify it to have the greetings inside a function. We've defined a greetFriends function that receives a list by parameter and iterates over that list, greeting each friend. But what if we only want to greet one friend instead of 4? Well, we still need to define a list, but with only one element. But first, let's see what would happen if we don't do that.
Greet friends. Very.
Huh, not what we expected, right? Well, what's going on here? This happens because strings are iterable. The for loop will go over each letter of the string and do the operation we asked it to do, which in this case, print a greeting. Depending on what you're trying to do, you may actually want to iterate through the letters of a string, but in this case we don't. So, to sum it up, if you get an error that a certain type isn't iterable, you need to make sure the for loop is using a sequence of elements and not just one. And if you find your code iterating through each letter of a string when you want it to do it for the whole string, you probably want to have that string be a part of a list. We've now learned how to write while loops and for loops. You might remember, for loops are best when you want to iterate over a known sequence of elements, but when you want to operate while a certain condition is true, while loops are the best choice. Next up, we've got a super useful cheat sheet for you that puts all this into one handy resource. After that, head over to the practice quiz to test your knowledge and check in on how you're doing. Welcome back. How are you feeling after the last quiz? We're starting to learn some pretty cool things that we could do in our code, right? And who knew loops could be so fascinating? We've now discovered two looping techniques that we could use in Python, while loops and for loops. We use while loops when we want to do an operation repeatedly while a certain condition is true. And we use for loops when we want to iterate over the elements of a sequence. Now, we're going to check out a third technique called recursion. But before we dive in, you may have noticed that this video is marked as optional. That's because while recursion is a very common technique used in software engineering, it's not used that much in automation. Still, we think it's valuable for you to know about recursion and to have an idea of how to use it. You may see it in code written by others, or you may face a problem where recursion is the best way to solve it. So while the next few videos are marked as optional and you won't be graded on their content, it's still super valuable stuff. Of course, feel free to skip them if you'd just rather focus on concepts you'll be graded on. Let's dive in. Recursion is the repeated application of the same procedure to a smaller problem. Have you ever played with a Russian nesting doll? They're a great visual example of recursion. Each doll has a smaller doll inside it. When you open up the doll to find the smaller one inside, you keep going until you reach the smallest doll, which can't be opened. Recursion lets us tackle complex problems by reducing the problem to a simpler one. Take our Russian nesting dolls, all nested inside each other, and imagine we want to find out how many dolls there are in total. We would need to open each doll one by one until we got to the last one, and then count how many dolls we've opened. That's recursion in action. Here's another example with a more complex problem. Imagine you're in a line of people and you want to know how many people are in front of you. And let me tell you, I can't stand long lines. Anyway, if the line's long, it might be hard to count the people without leaving the line and losing your place. So instead, you could ask the person in front of you how many people are in front of them. Since this person will be in the same situation as you, they'll have to ask the same question to the person in front of them, and so on until the question reaches the first person in the line. This person can confidently reply that there are no people in front of them. So then, the second person in line can reply 1, the person behind them replies 2, and so on until the answer reaches you. Okay, I know the chances are pretty small that all those people would play along just so you can know where you are in line, but it's a useful way to visualize how recursion works. How does this translate into programming? Well, in programming, recursion is a way of doing a repetitive task by having a function call itself. A recursive function calls itself, usually with a modified parameter, until it reaches a specific condition. This condition is called the base case. In our earlier examples, the base case would be the smallest Russian doll, or the person at the front of the queue. Let's check out an example recursive function to understand what we're talking about. Here, we're defining a function called factorial. At the beginning of the function, we have a conditional block defining the base case, where n is smaller than 2. It simply returns the value 1. After the base case, we have a line where the factorial function is calling itself with n minus 1. This is called the recursive case. And this creates a loop. each time the function is executed, it calls itself with a smaller number until it reaches the base case. Once it reaches the base case, it returns the value 1, and then the previously called function multiplies that by 2, and the previously called function multiplies it by 3, and so on. This loop will keep going until the first factorial function called returns the desired result. It's a bit complex, right? Let's add a few print statements to see exactly how this works. So here we can see the function kept calling itself until it reached the base case. After that, each function returned the value of the previous function multiplied by n until the original function returned. Cool, huh? Next up, we're going to check out some more examples of when to use recursion and when it's best to avoid it. By now, you've seen what a recursive function looks like, how to write a base case and a recursive case. You might be wondering, why do we need recursive functions if I can just use a for or while loop? Well, solutions to some specific problems are easier to write and understand when using recursive functions. A lot of math functions, like the factorial or the sum of all the previous numbers, are good examples of this. If a math function is already defined in recursive terms, it's straightforward to just write the code as a recursive function. But it's not just about math functions. Let's check out a couple of examples of how this could help an IT specialist trying to automate tasks. Let's say that you need to write a tool that goes through a bunch of directories in your computer and calculates how many files are contained in each. When listing the files inside a directory, you might find subdirectories inside them, and you'd want to count the files in those subdirectories as well. This is a great time to use recursion. The base case would be a directory with no subdirectories. For this case, the function would just return the amount of files. The recursive case would be calling the recursive function for each of the contained subdirectories. The return value of a given function call would be the sum of all the files in that directory plus all the files in the contained subdirectories. A directory of files that can contain other directories is an example of a recursive structure, because directories can contain subdirectories that contain subdirectories that contain subdirectories, and so on. When operating over a recursive structure, it's usually easier to use recursive functions than for or while loops. Another IT-focused example of a recursive structure is anything that deals with groups of users that can contain other groups. We see this situation a lot when using administrative tools like Active Directory or LDAP. Say your group management software allows you to create groups that have both users and other groups as their members, and you want to list all human users that are part of a given group. Here, you would use a recursive function to go through the groups. The base case would be a group that only includes users, listing all of them. The recursive case would mean going through all the groups contained, listing all the users in them, and then listing any users contained in the current group. It's important to call out that in some languages, there's a maximum amount of recursive calls you can use. In Python, by default, you can call a recursive function 1,000 times until you reach the limit. That's fine for things like subdirectories or user groups that aren't thousands of levels deep, but it might not be enough for mathematical functions like the ones we saw in the last video. Let's go back to our factorial example from the last video and try to call it with n equals 1,000.
Factorial 1000.
See that error? It's telling us that we've reached the maximum limit for recursive calls. So while you can use recursion in a bunch of different scenarios, we only recommend using it when you need to go through a recursive structure that won't reach 1,000 nested levels. All right, we've just added recursion to your growing scripting toolbox. They're ready for you whenever the situation calls for it. Welcome back, and congratulations on getting this far. I sure am glad we didn't lose you in all those loops we covered in the last module. You're doing great and making tons of progress. In earlier videos, we covered the basic elements of Python syntax. We talked about how to define functions, how to make your computer act differently based on conditionals, and how to make it perform operations repeatedly using while and for loops and recursion. Now that we have the basics of syntax out of the way, we can start growing our Python knowledge, which will let us do more and more interesting operations. Remember, one of our main goals in this course is to help you learn to write short Python scripts that automate actions. You've made big steps towards getting there. And in the upcoming videos, we're going to learn a bunch of new, super useful skills to add to your programming toolbox. We'll check out some data types provided by the Python language to help us solve common problems with our scripts. In particular, we'll do a deep dive into strings, lists, and dictionaries. Heads up, while we've used strings in our scripts already, we barely scratched the surface of all the things we can do with them in Python. We also ran into a few lists in some examples, but there's a lot more of them we haven't seen yet. And dictionaries are a whole new data type for us to dig our teeth into. These are all data types, or data structures, that are super flexible. We're going to use them to write all kinds of scripts in Python. So it's a good idea to spend some time getting to know them and learning when to use them and how to make the most out of them. We've got a lot of new and exciting concepts to discover, so let's get right to it. By now, we've used strings in a lot of examples, but we haven't spent time looking at them in detail yet. Before we dive into the nitty-gritty though, let's go over what we've seen so far and add a few more points. First, a quick refresher. A string is a data type in Python that's used to represent a piece of text. It's written between quotes, either double quotes or single quotes, your choice. It doesn't matter which type of quotes you use as long as they match. If we mix up double and single quotes, Python won't be too happy and it'll return a syntax error, telling us it couldn't find the end of the string. A string can be as short as 0 characters, usually called an empty string, or really long. We also learned that we can use strings to build longer strings using the plus sign, an action called concatenating. A less common operation is to multiply the string by a number, which multiplies the content of the string that many times, like this. If we want to know how long a string is, we can use the len function, which we saw in earlier videos. The len function tells us the number of characters contained in the string. We can use strings to represent a lot of different things. They can hold a username, the name of a machine, an email address, the name of a file, and any other text. A lot of the data that we'll interact with will be stored in strings, so it's important to know how to use them. There are tons of things we could do with strings in our scripts. For example, we can check if files are named a certain way by looking at the file name and seeing if they match our criteria. Or we can create a list of emails by checking out the users of our system and concatenating our domain. I recently wrote a script that worked with a bunch of files and took different actions according to the name of each file. So if the file ended in a certain extension, say .txt, then my script would print it. If the file had a certain string in the name, say test, then my script would ignore it and move on to the next thing, and so on. The contents of a text file are also strings. A few months ago, I had to change the default values for a bunch of configuration options from true to false. So I wrote a function that would find the string true in a file and replace it with false. You can probably think of more examples where your code needs to handle strings, but to use strings effectively, we need to know what options are available to us in Python. In the next few videos, we'll cover some of the operations we can perform over strings, including how to access parts of them and modify them. When we first came across the for loop, we called out that we can iterate over a string character by character. But what if we want to access just a specific character or characters? We might want to do this, for example, if we have a text that's too long to display and we want to show just a portion of it. Or if we want to make an acronym by taking the first letter of each word in a phrase. We can do that through an operation called string indexing. This operation lets us access the character in a given position or index using square brackets and the number of the position we want, like this. This might seem confusing at first, like Python is acting up. We're asking for the first character and it's giving us the second. What gives, Python? Well, what's happening here is that Python starts counting indexes from 0, not 1, just like it does with the range function. So if we want the first character, we need to access the one at index 0. Knowing that indexes start at 0, which one do you think will be the last index in the string? It'll always be one less than the length of the string. In this case, our string has 6 characters, so the last index will be 5. Let's try it out. We see that the character in position 5 is the last character of the string. And if we try to access index 6, we get an index error telling us that it's out of range. We can only go up to length minus 1. Well, what if you want to print the last character of a string, but you don't know how long it is? You can do that using negative indexes. Let's see that in a different example. In this example, we don't know the length of the string, but it doesn't matter. Using negative indexes lets us access the positions in the string starting from the last. Nice, right? On top of accessing individual characters, we can also access a slice of a string. A slice is the portion of a string that can contain more than one character, also sometimes called a substring. We do that by creating a range using a colon as a separator. Let's see an example of this. The range we use when accessing a slice of a string works just like the one created by the range function. It includes the first number, but goes up to one less than the last number. In this case, we start with index 1, the second letter of the string, and go up to index 3, the fourth letter of the string. Another option for the range is to include only one of the two indexes. In that case, it's assumed that the other index is either 0 for the first value or the length of the string for the second value. Check this out. Accessing the slice from nothing to 4 takes the first 4 characters of the string, indexes 0 to 3. Accessing the slice from 4 to nothing takes everything from index 4 onward. All of this indexing might seem confusing at first. Don't worry, we all took time to wrap our heads around it. Just like all the challenges we've come across so far, the key is to keep practicing until you master it. And there are a bunch of exercises ahead to help you with that. Now that we know how to select, slice, and access the parts of the string we want, we're going to learn how to modify them. That's coming up next. In the last video, we saw how to access certain characters inside a string. Now, what if we wanted to change them? Imagine you have a string with a character that's wrong and you want to fix it, like this one. Taking into account what you learned about string indexing, you might be tempted to fix it by accessing the corresponding index and changing the character. Let's see what happens if we try that. Oops, these pesky type errors, right? In this case, we're told that strings don't support item assignment. This means that we can't change individual characters because strings in Python are immutable, which is just a fancy word meaning they can't be modified. What we can do is create a new string based on the old one, like this. Nice! We fixed the typo. But does this mean the message variable can never change? Not really. We can assign a new value to the same variable. Let's do that a couple of times to see how it works. What we're doing here is giving the message variable a whole new value. We're not changing the underlying string that was assigned to it before. We're assigning a whole new string with different content. If this seems a bit complex, that's okay. You don't need to worry about this right now. We'll call this out whenever it's relevant for the program we're writing. So we figured out how to create a new message from the old one, but how are we supposed to know which character to change? Let's try something different. In this case, we're using a method to get the index of a certain character. A method is a function associated with a specific class. We'll talk a lot more about classes and methods later. For now, what you need to know is that this is a function that applies to a variable, and we can call it by following the variable with a dot. Let's try this a few more times. So the index method returns the index of the given substring inside the string. The substring that we pass can be as long or as short as we want. What if there's more than one of the substring? Here, we know there are two S characters, but we only get one value. That's because the index method returns just the first position that matches. And what happens if the string doesn't have the substring we're looking for? The index method can't return a number because the substring isn't there, so we get a value error instead. We said that if the substring isn't there, we would get an error. So how can we know if a substring is contained in a string to avoid the error? Let's check this out. We can use the keyword in to check if a substring is contained in a string. We came across the keyword in when using for loops. In that case, it was used for iteration. Here, it's a conditional that can be either true or false. It'll be true if the substring is part of the string, and false if it's not. So here, the dragon's substring isn't part of the string, and sadly, we can't have a dragon as a pet. All right. We just covered a bunch of new things, and you're doing awesome. Let's put all this stuff together to solve a real-world problem. Imagine that your company has recently moved to using a new domain, but a lot of the company email addresses are still using the old one. You want to write a program that replaces this old domain with the new one in any outdated email addresses. The function to replace the domain would look like this. This function is a bit more complex than others, so let's go through it line by line. First, we define the replace domain function, which accepts three parameters: the email address to be checked, the old domain, and the new domain. Having all these values as parameters instead of directly in the code makes our function reusable. We aren't just changing one domain to the other. We have a function that will work with all domains. Pretty sweet! In the first line of the body of the function, we check if the concatenation of the @ and the old domain are contained in the email address using the keyword in. We check this to make sure the email has old domain on the portion that comes after the @. If the condition is true, the email address needs to be updated. To do that, we first find out the index where the old domain, including the @ starts. We know that this index will be a valid number because we've already checked that the substring was present. So, using this index, we create the new email. This is a string that contains the first portion of the old email up until the index we had calculated, followed by the @ and the new domain. Finally, we return this new email. If the email didn't contain the new domain, then we can just return it, which is what we do in the last line. Wow, that was a really complex function with a lot of new things in it, so don't worry if you're finding it a bit tricky. Rewatch the video and take your time. If there's a specific part that's tripping you up, remember, you can always ask your fellow learners for help in the discussion forum. You may even find that someone has asked and got the answer to the same question already. When you feel ready to move on, meet me over in the next video where we're going to learn a lot more handy string methods. We said earlier that we had a lot of new exciting concepts coming up. Well, I'm not going to string you along anymore. We're going to tie up our lessons on strings with a bunch of fun methods for transforming our string text. I know. My jokes are pretty terrible, so let's get back to the good stuff. So far, we've seen ways you can access portions of strings using the indexing technique, create new strings by slicing and concatenating, find characters in strings using the index method, and even test if one string contains another. On top of all this string processing power, the string class provides a bunch of other methods for working with text. Now we'll show you how to use some of these methods. Remember, the goal is not for you to memorize all of this. Instead, we want to give you an idea of what you can do with strings in Python. Some string methods let you perform transformations or formatting on the string text, like upper and its opposite, lower. These methods are really useful when you're handling user input. Let's say you wanted to check if the user answered yes to a question. How would you know if the user typed it using upper or lowercase? You don't need to. You just transform the answer to the case you want. Like this example. Another useful method when dealing with user input is the strip method. This method will get rid of surrounding spaces in the string. If we ask the user for an answer, we usually don't care about any surrounding spaces, so it's a good idea to use the strip method to get rid of any white space. This means that strip doesn't just remove spaces, it also removes tabs and newline characters, which are all characters we don't usually want in user-provided strings. There are two more versions of this method, lstrip and rstrip, to get rid of the white space characters just to the left or to the right of the string instead of both sides. Other methods give you information about the string itself. The method count returns how many times a given substring appears within a string. The method endsWith returns whether the string ends with a certain substring. The method isNumeric returns whether the string's made up of just numbers. Adding to that, if we have a string that is numeric, we can use the int function to convert it to an actual number. In earlier videos, we showed that we can concatenate strings using the plus sign. The join method can also be used for concatenating. To use the join method, we have to call it on the string that'll be used for joining. In this case, we're using a string with a space in it. The method receives a list of strings and returns one string with each of the strings joined by the initial string. Let's check out another example. Finally, we can also split a string into a list of strings. The split method returns a list of all the words in the initial string, and it automatically splits by any white space. It can optionally take a parameter and split the strings by another character, like a comma or a dot. Are you starting to see how these string methods could be useful in your IT job? Okay, so we've just learned a bunch of new methods, but there are tons more that you can use on strings. We've included a list with the ones we talked about and some new ones in the next cheat sheet. You'll also find a link to the full Python documentation there, which gives you all the info on each available method. As we've said before, don't worry about trying to memorize everything. You'll pick these concepts up with practice, and the documentation is always there if you need it. All right, last up in our string of string videos, we're going to check out how to format strings. Up to now, we've been making strings using the plus sign to just concatenate the parts of the string we wanted to create. And we've used the str function to convert numbers into strings so that we can concatenate them too. This works, but it's not ideal, especially when the operations you want to do with the string are on the tricky side. There's a better way to do this, using the format method. Let's see a couple of examples. In this example, we have two variables, name and number. We generate a string that has those variables in it by using the curly brackets placeholder to show where the variables should be written. We then pass the variables as a parameter to the format method. See how it doesn't matter that name is a string and number is an integer? The format method deals with that, so we don't have to. Pretty neat, right? The curly brackets aren't always empty. By using certain expressions inside those brackets, we can take advantage of the full power of the format expression. Heads up, this can get complex fast. If at any point you get confused, don't panic. You only really need to understand the basic usage of the format method we just saw. One of the things we can put inside the curly brackets is the name of the variable we want in that position to make the whole string more readable. This is particularly relevant when the text can get rewritten or translated and the variables might switch places. In our earlier example, we could rewrite the message to make the variables appear in a different order. In that case, we'd need to pass the parameters to format in a slightly different way. Because we're using placeholders with variable names, the order in which the variables are passed to the format function doesn't matter. But for this to work, we need to set the names we're going to use and assign a value to them inside the parameters to format. And that's just the tip of the iceberg of what we can do with the format method. Want to dive a little deeper? Great, let's keep on going. We're going to check out a different example. Let's say you want to output the price of an item with and without tax. Depending on what the tax rate is, the number might be a long number with a bunch of decimals. So if something costs $7.5 without tax and the tax rate is 9%, the price with tax would be $8.175. First off, ouch. And also, since there's no such thing as half a penny anymore, that number doesn't make sense. So to fix this, we can make the format function print only 2 decimals, like this. In this case, between the curly brackets, we're writing a formatting expression. There are a bunch of different expressions we can write. These expressions are needed when we want to tell Python to format our values in a way that's different from the default. The expression starts with a colon to separate it from the field name that we saw before. After the colon, we write .to f. This means we're going to format a float number and that there should be 2 digits after the decimal dot. So no matter what the price is, our function always prints 2 decimals. Remember when we did the table to convert from Fahrenheit to Celsius temperatures? Our table looked kind of ugly because it was full of float numbers that had way too many decimal digits. Using the format function, we can make it look a lot nicer. In these 2 expressions, we're using the greater than operator to align text to the right so that the output is neatly aligned. In the first expression, we're saying we want the numbers to be aligned to the right for a total of 3 spaces. In the second expression, we're saying we want the number to always have exactly 2 decimal places, and we want to align it to the right at 6 spaces. We can use string formatting like this to make the output of our program look nice, and also to generate useful logging and debugging messages. Over the course of my sysadmin career, I've grown used to formatting strings to create more informative error messages. They help me understand what's going on with a script that's failing. There's a ton more formatting options you can use when you need them, but don't worry about learning them all at once. We'll explain any others as they come along, and we'll put everything in a cheat sheet that you can refer to whenever you need a formatting expression. Let's take a look at that now, and then we'll have a quiz to help you get more familiar with all this new knowledge. As you know by now, Python comes with a lot of ready-to-use data types. We've seen integers, floats, booleans, and strings in detail. But those data types can only take you so far. Eventually, in your scripts, you'll want to develop code that manipulates collections of items, like a list of strings representing all the file names in a directory, or a list of integers representing the size of network packets. This is where the list data type comes in handy. You can think of lists as long boxes, with the space inside the box divided up into different slots. Each slot can contain a different value. Like we mentioned earlier when we first came across the list, in Python we use square brackets to indicate where the list starts and ends. Let's check out an example. Here we've created a new variable called x and set its contents to be a list of strings. We can check the type of x using the type function we saw a little while ago. Nice! Python tells us this is a list. In the same way we've done with other variables, we can show the contents of the whole list using the print function. The length of the list is how many elements it has. To get that value, we'll use the same len function we used for strings. That's right, our list has 4 elements. When calling len for the list, it doesn't matter how long each string is on its own. What matters is how many elements the list has. To check if a list contains a certain element, you can use the keyword in, like in these examples. Again, like when we used this with strings, the result of this check is a Boolean, which we can use as a condition for branching or looping. We can also use indexing to access individual elements depending on their position in the list. To do that, we use the square brackets and the index we want to access, exactly like we did with strings. Remember that the first element is given the index 0. This means the last index of the list will be the length of the list minus 1. What happens if we try to access an element after the end of the list? You might have seen this coming. We get an index error. We can't go over the end of the list. Remember that because list indexes start at 0, accessing the item at index 4 means we're trying to access the 5th element in the list. There are only 4 elements, so we're out of range if we try to access the index number 4. Does this seem a bit confusing? If it does, this visualization might help you out. As you can see, index 4 doesn't point at anything since there's no slot 4 in our list. As with strings, we can also use indexes to create a slice of the list. For this, we use ranges of 2 numbers separated by a colon. Again, the second element isn't included in the slice, so the range goes to the second index minus 1. Here, we start at index 1 and go up to 1 less than 3, which is 2. We can also leave out one of the range indexes empty. The first value defaults to 0 and the second value to the length of the list. Make sense? If all this sounds really familiar to what we said about strings, then this course is working as intended. That's because strings and lists are very similar data types. In Python, strings and lists are both examples of sequences. There are other sequences too, and they all share a bunch of operations, like iterating over them using for loops, indexing, using the len function to know the length of the sequence, using plus to concatenate 2 sequences, and using in to verify if the sequence contains an element. So this is great news. While understanding indexing is hard, once you know it for one data type, you've pretty much mastered it for every data type. So you actually know way more than you thought. Wow, now we're really cooking. Next up, we're going to look at some more list operations, this time actually specific to lists. One of the ways that lists and strings are different is that lists are mutable, which is another fancy word to say that they can change. This means we can add, remove, or modify elements in a list. Let's go back to our example of thinking of a list as a long box. Changing the list means we keep the same box and we add, remove, or change the elements inside that box. We'll now go through the methods that let us modify the list one by one. If all these details seem a little overwhelming, that's okay. As usual, there will be a cheat sheet at the end and you'll have lots of chances to practice each of these methods as we go along. You don't need to learn all those by heart, and of course, you can always review anything that isn't clear. So don't worry, we've got your back. We'll start with the simplest change, adding an element to a list using the append method. Let's check this out in the tastiest example yet. The append method adds a new element at the end of the list. It doesn't matter how long the list is, the element always gets added to the end. You could start with an empty list and add all of its items using append. If you want to insert an element in a different position instead of at the end, you can use the insert method. The insert method takes an index as the first parameter and an element as the second parameter. It adds the element at that index in the list. To add it as the first element, we use index 0, and we can use any other number. What happens if we use a number larger than the length of the list? Woohoo! No errors! You can say that it even worked just peachy. If we use an index higher than the current length, the element just gets added to the end. You can pass any number to insert, but usually you either add at the beginning using insert at the 0 index or at the end using append. We can also remove elements from the list. We can do it using the value of the element we want to remove. Can you guess what method we would use? You got it! Use the remove method. The remove method removes from the list the first occurrence of the element we passed to it. What happens if the element is not in the list? Oof, that went pear-shaped. We got a value error telling us the element isn't in the list. Another way we can remove elements is by using the pop method, which receives an index. The pop method returns the element that was removed at the index that was passed. And the last way to modify the contents of a list is to change an item by assigning something else to that position, like this. Wow, the contents of our fruits variable have changed a lot since we started this video, but it's always the same variable, the same box. We've just modified what's inside. Modifying the contents of lists will come up in tons of scripts as we operate with them. If the list contains hosts on a network, you could add or remove hosts as they come online or offline. If the list contains users authorized to run a certain process, you could add or remove users when permissions are granted or removed, and so on. You've now seen a number of methods that let us modify the contents of a list, adding, removing, and changing the elements that are stored inside the list. Whenever you need to write a program that'll handle a variable amount of elements, you'll use a list. What if you need a sequence of a fixed amount of elements? That's coming up in our next video. As we called out before, there are a number of data types in Python that are all sequences. Strings are sequences of characters and are immutable. Lists are sequences of elements of any type and are mutable. A third data type that's a sequence and also closely related to lists is the tuple. Tuples are sequences of elements of any type that are immutable. We write tuples in parentheses instead of square brackets. You might be wondering, why do we even need another sequence type? Weren't lists great? Yes, lists are great. They can hold any number of elements, and we can add, remove, and modify their contents as much as we want. But there are cases when we want to make sure an element in a certain position or index refers to one specific thing and won't change. In these situations, lists won't help us. Thanks for nothing, lists. In our example, we have a tuple that represents someone's full name. The first element of the tuple is the first name, the second element is the middle initial, and the third element is the last name. If we add another element somewhere in there, what would that element represent? It would just be confusing and our code wouldn't know what to do with it, and that's why modifying isn't allowed. In other words, when using tuples, the position of the elements inside the tuple have meaning. Tuples are used for lots of different things in Python. One common example is the return value of functions. When a function returns more than one value, it's actually returning a tuple. Remember the function to convert seconds to hours, minutes, and seconds that we saw a while back? Here it is to remind you. This function returns 3 values. In other words, it returns a tuple of 3 elements. Let's give it a try. see the result as a tuple. What if we print it? We see that it has the 3 elements we expect it to have. And remember, since this is a tuple, the order matters. The first element represents the hours, the second one represents the minutes, and the third represents the seconds. One interesting thing we can do with tuples is unpack them. This means that we can turn a tuple of 3 elements into 3 separate variables. And because the order won't change, we know what those variables represent. Like this. So, now we've split the tuple into 3 separate values. We've seen before that we can also do this directly when calling the function without the intermediate result variable. In Python, it's really common to use tuples to represent data that has more than one value and that needs to be kept together. For example, you could use a tuple to have a file name and its size, or you could store the name and email address of a person, or a date and time and the general health of a system at any point in time. Can you see how these different data types could help you automate some of your IT work? Pretty cool, right? Knowing when to use tuples and when to use lists can seem a little fuzzy at first, but don't worry, it'll get clearer as we tackle more examples. When we looked at for loops, we said they iterate over a sequence of elements. One of the examples we checked out was iterating over a list. Let's take a little trip to the zoo to see this in action.
Okay, so we will make a list of animals. So animals equals, and since we're making a list, we'll start with a bracket. And we'll add lion, zebra, dolphin, and monkey, and end the list with another bracket. Chars equals 0, and we'll start a loop. For animal in animals, 2 spaces, chars, plus equals length of animals. Print total characters average length dot format chars length animals.
In this code, we're iterating over a list of strings. For each of the strings, we get its length and add it to the total amount of characters. At the end, we print the total and the average, which we get by dividing the total by the length of the list. You can see we're using the len function twice, once to get the length of the string, and then again to get the amount of elements in the list. What if you wanted to know the index of an element while going through the list? You could use the range function and then use indexing to access the elements at the index that range returned. You could use a range function and then use indexing to access the elements at the index that range just returned. Or you could just use the enumerate function.
Winners equals, we'll make a list, Ashley, Dylan, and Reese, and close the list. For index, person, in, enumerate, winners, print, curly brackets, dash, curly brackets, dot, format, index, plus 1, person.
The enumerate function returns a tuple for each element in the list. The first value in the tuple is the index of the element in the sequence. The second value in the tuple is the element in the sequence. You're the real winner with the enumerate function. It does all the work for you. Pretty useful, right? Let's use all of this now to solve a slightly more interesting problem. Say you have a list of tuples containing 2 strings each. The first string is an email address, and the second is the full name of the person with that email address. You want to write a function that creates a new list containing 1 string per person, including their name and the email address between angled brackets, the format usually used in emails, like this. So, what do we need to do? We'll start by defining a function that receives a list of people.
Def full emails takes the argument people.
Remember, people is a list of tuples where the first element is the email address and the second one is the full name. So in our function, we'll first create the variable that we'll use as a return value, which will be a list, and we'll call it result.
Result equals empty list.
We'll then iterate over the list of people. We know this list contains tuples of 2 strings each, so we'll unpack the values directly when iterating in variables that we'll call email and name.
For email and name in people,
now our result variable is a list, and it should contain strings, so we'll append the resulting string to the results list.
Result.append.
The string that we'll append will be formatted in the way we want. To do that, we'll use the format method with the 2 variables of our iteration.
So curly brackets, dot format, name, and email.
Once we're done with the iteration, we'll return the list, which should now contain all the necessary emails.
Return result.
Will this work? What do you think? Let's try it out.
Print full emails. alex@example.com. Alex Diego. Shay@example.com is the email, and we'll call Shay Brand as the name.
Yes, this worked as expected. Before we move on, a quick word of caution about some common errors when dealing with lists in Python. Because we use the range function so much with for loops, you might be tempted to use it for iterating over indexes of a list, and then to access the elements through indexing. You could be particularly inclined to do this if you're used to other programming languages before. Because in some languages, the only way to access an element of a list is by using indexes. Real talk. This works, but looks ugly. It's more idiomatic in Python to iterate through the elements of the list directly, or using enumerate when you need the indexes, like we've done so far. There are some specific cases that do require us to iterate over the indexes. For example, when we're trying to modify the elements of the list we're iterating. By the way, if you're iterating through a list and you want to modify it at the same time, you need to be very careful. If you remove elements from the list while iterating, you're likely to end up with an unexpected result. In this case, it might be better to use a copy of the list instead. We've now seen a bunch of different things we can do with lists, and hopefully you're starting to see how they can be a very powerful tool in your IT specialist toolkit. Next up, we're going to learn a powerful technique for creating lists. We're almost done with our deep dive into Python lists. But before we continue to our next data structure, let's talk about creating lists in a shorter way. Say we wanted to create a list with multiples of 7, from 7 to 70. We could do it like this.
So we create a list called multiples. Then, for x in range 1 to 11, multiples dot append x times 7. Print multiples.
This works fine and is a good way of solving it, but because creating lists based on sequences is such a common task, Python provides a technique called list comprehension that lets us do it in just one line. This is how we would do the same with list comprehension.
Multiples equals, we'll start the list, x times 7 for x in range 1 to 11, and close the list. Print multiples. It should be the same.
List comprehensions let us create new lists based on sequences or ranges. So we can use this technique whenever we want to create a list based on a range, like in this example, or based on the contents of a list, a tuple, a string, or any other Python sequence. The syntax tries to copy how you would express these concepts with natural language, although it can still be confusing sometimes. Let's check out a different example. Say we have a list of strings with the names of programming languages, like this one, and we want to generate a list of the lengths of the strings. We could iterate over the list and add them using append like we did before, or we could use a list comprehension, like this.
Lengths equals len language for language in languages. Print lengths.
List comprehensions also let us use a conditional clause. Say we wanted all the numbers that are divisible by 3 between 0 and 100. We could create a list like this.
Z equals open list x for x in range 0 to 101 if x modulo 3 equals 0. Print z.
In this case, we just want the element x to be a part of the list, but we only want the numbers where the remainder of the division by 3 is 0. So we add the conditional clause after the range. Using list comprehensions when programming in Python is totally optional. Sometimes it can make the code look nicer and more readable. At other times, it can have the opposite effect, especially if we try to pack too much information together. In general, it's a good idea to know that list comprehensions exist, especially when you're trying to understand someone else's code. All right, we've now seen a bunch of different methods we can use to operate with lists and tuples, and Python provides even more of them that we didn't get to talk about. In our next reading, you'll find a list of the most common operations and links to the official documentation in case you want to learn more. After the reading, you can practice your new skills in the next quiz. Welcome back! The first time we talked about list comprehensions, we showed you how to create a list using a for loop. Then we showed you how to create that same list using a list comprehension. If you're anything like me, you're probably wondering why there are two ways to do the same thing. So how do you know which one to use? In this video, we're going to talk about when to use a for loop and when to use a list comprehension. But first, a quick review. We said a for loop iterates or repeats over a sequence of values like numbers, letters, and so on. A list comprehension lets us create new lists based on sequences or ranges. It's basically a shorthand way to build a new list based on the contents of an existing list. The list comprehension has the for loop, the compilation, and builds the list all in a single line of code. List comprehensions and for loops both do the same thing. So when should you use which one? The short answer is, it's your call. Both methods are essentially interchangeable, so there are no standards or best practices. Deciding when to use a list comprehension instead of a for loop or vice versa is totally up to you. That said, there are considerations that many programmers make when deciding whether to use a list comprehension or a for loop. Programmers tend to use a list comprehension when it's fairly simple code, such as filtering a list to pull out items that match or capitalizing words in a list. If it can fit on a single line, I'd probably make it a list comprehension, which you can see in this example. For more complex code, it's usually a good idea to use a for loop. A for loop spells out the process better, which will make it easier for you and other programmers to read and maintain the code you write. For example, let's say you're working for a company that maintains a list of invoices. You need to calculate the sales tax and balance due for all the items on the list. You want to start with updating the status of past due invoices. You could accomplish this with a list comprehension, but it would be complicated and likely confusing to read and understand. Let's go over an example of what the list comprehension would look like for updating the status of past due invoices. In this code, we create a list called past due that contains all of the invoices in the invoices list that are more than 30 days old and have not yet been paid. I is used in the list comprehension to iterate over the invoices list. Then, for j in past due iterates over the past due list and sets the status of each invoice to past due. J is used in the for loop to iterate over the past due list. In this case, a for loop would be preferable because it clearly lays out all the steps the code is going through, so other programmers can read and understand it quickly. Here's an example of what that looks like. This for loop iterates over the invoices list and sets the attribute of each invoice to past due if the invoice is more than 30 days old and has not been paid yet. This code will have the same result as the list comprehension we just went over, but it's more straightforward. This makes it easier to code and understand. So let's loop back to the question we asked earlier. When should you use a for loop, and when should you use a list comprehension? Here are some questions to ask yourself to guide your decision. Which one will make my code both clear and concise? And which one will make my code easier for other people to read and understand? It's important to keep in mind that most developers like their code short, sweet, and to the point. Finally, remember that whatever code writing strategy you choose, use meaningful names for all your variables, data sets, and lists. Always assume others will see your code. And now that you're armed with the information to make the best decisions, you can continue building your knowledge and skills as you dive deeper into Python. How are you feeling so far? Lists and strings are pretty cool, right? These tools let us do a ton of neat stuff in our code, so they can be super fun to experiment with. We're now going to learn about another data type, dictionaries. Like lists, dictionaries are used to organize elements into collections. Unlike lists, you don't access elements inside dictionaries using their position. Instead, the data inside dictionaries take the form of pairs of keys and values. To get a dictionary value, we use its corresponding key. Another way these two vary is while in a list the index must be a number, in a dictionary you can use a bunch of different data types as keys, like strings, integers, floats, tuples, and more. The name dictionaries comes from how they work in a similar way to human language dictionaries. In an English language dictionary, the word comes with a definition. In the language of a Python dictionary, the word would be the key and the definition would be the value. Make sense? Let's check out an example. You can create an empty dictionary in a similar way to creating an empty list, except instead of square brackets, dictionaries use curly brackets to define their content. Once again, we can use the type function to check that the variable we've just created is a dictionary.
X equals, open brackets, type X.
Creating initialized dictionaries isn't too different from the syntax we used in earlier videos to create initialized lists or tuples. But instead of a series of slots with values in them, we have a series of keys that point at values. Okay, let's check out an example dictionary.
We'll call it file counts equals, and then open bracket, JPEG 10, text 14, CSV 2, and PY 23. print file counts.
In this file counts dictionary, we've stored keys that are strings, like JPEG, that point at integer values like 10. When creating the dictionary, we use colons in between the key and the value and separate each pair by commas. In a dictionary, it's perfectly fine to mix and match the data types of keys and values like this, and can be very useful. In this example, we're using a dictionary to store the number of files corresponding to each extension. It makes sense to encode the file extension formatting in a string, while it's natural to represent a count as an integer number. Let's say you want to find out how many text files there are in the dictionary. To do this, you would use the key txt to access its associated value. The syntax to do this may look familiar, since we use something similar in our examples of indexing strings, lists, and tuples.
File counts, open bracket, txt.
You can also use the in keyword to check if a key is contained in a dictionary. Let's try a couple of keys.
JPEG in file counts, true. HTML in file counts, false.
Dictionaries are mutable. You might remember what mutable means from an earlier video. That's right, it means we can add, remove, and replace entries. To add an entry in a dictionary, just use the square brackets to create the key and assign a new value to it. Let's add a file count of 8 for a new CFG file extension in our dictionary.
File counts, open bracket, add CFG, close bracket, equals 8, and then print file counts.
Oh, this brings up an interesting point about dictionaries. What do you think will happen if we try to add a key that already exists in the dictionary?
File counts, open bracket, CSV, close bracket, equals 17. Print file counts.
When you use a key that already exists to set a value, the value that was already paired with that key is replaced. As you can see in this example, the value associated with the CSV key used to be 2, but it's now 17. The keys inside of a dictionary are unique. If we try to store two different values for the same key, we'll just replace one with the other. Last off, we can delete elements from a dictionary with the del keyword by passing the dictionary and the key to the element as if we were trying to access it.
Del file counts, open bracket, CFG, close bracket, and print file counts.
What do you think? Dictionaries seem pretty useful, right? We've now seen how to create a dictionary and how to add, modify, and delete elements stored in the dictionary. Up next, we'll discover some interesting things we can do with them. It probably won't come as a surprise that, just like with strings, lists, and tuples, you can use for loops to iterate through the contents of a dictionary. Let's see how this looks in action.
So file counts equals, open bracket, JPEG 10, comma, TXT 14, comma, CSV 2, comma, PY 23, and then close bracket. And then for extension in file counts, 2 spaces, print extension.
So if you use a dictionary in a for loop, the iteration variable will go through the keys in the dictionary. If you want to access the associated values, you can either use the keys as indexes of the dictionary, or you can use the items method, which returns a tuple for each element in the dictionary. The tuple's first element is the key, its second element is the value. Let's try that with our example dictionary.
For extension amount in file counts dot items, print there are, and then brackets, files with the dot brackets extension dot format amount extension.
Sometimes you might just be interested in the keys of a dictionary. Other times you might just want the values. You can access both with their corresponding dictionary methods, like this.
File counts dot keys, file counts dot values.
These methods return special data types related to the dictionary, but you don't need to worry about what they are exactly. You just need to iterate them as you would with any sequence.
For value in file counts dot values, print value.
So we can use items to get key value pairs, keys to get the keys, and values to get just the values. Not too hard, right? Because we know that each key can be present only once, dictionaries are a great tool for counting elements and analyzing frequency. Let's check out a simple example of counting how many times each letter appears in a piece of text. In this code, we're first initializing an empty dictionary, then going through each letter in the given string. For each letter, we check if it's not already in the dictionary, and in that case, we initialize an entry in the dictionary with a value of 0. Finally, we increment the count for that letter in the dictionary. To sum up, we've created a dictionary where the keys are each of the letters present in the string, and the values are how many times each letter is present. Let's try out a few example strings.
Count letters, let's say A. Count letters, tenant. Count letters, and this time we'll say a long string with a lot of letters.
Here you can see how the dictionary can have any number of entries, and the pairs of key values always count how many of each letter there are in the string. Also, do you see how our simple code doesn't distinguish between actual letters and special characters like a space? To only count the letters, we'd need to specify which characters we're taking into account. This technique might seem simple at first, but it can be really useful in a lot of cases. Let's say, for example, that you're analyzing logs in your server and you want to count how many times each type of error appears in the log file. You could easily do this with a dictionary by using the type of error as the key and then incrementing the associated value each time you come across that error type. Are you starting to see how dictionaries can be a really useful tool when writing scripts? Coming up, we're going to learn how to tell when to use dictionaries and when to use lists. Dictionaries and lists are both really useful and each have strengths in different situations. So when is it best to use a list and when's a dictionary the way to go? Think about the kind of information you can represent in each data structure. If you've got a list of information you'd like to collect and use in your script, then a list is probably the right approach. For example, if you want to store a series of IP addresses to ping, you could put them all into a list and iterate over them. Or if you had a list of host names and their corresponding IP addresses, you might want to pair them as key values in a dictionary. Because of the way dictionaries work, it's super easy and fast to search for an element in them. Let's say you have a dictionary that has usernames as keys and the groups they belong to as values. It doesn't matter if you have 10 users or 10,000 users. Accessing the entry for a given user will take the same time. Amazing! But this isn't true for lists. If you've got a list of 10 elements and you need to check if one element is in the list, it'll be a very fast check. But if your list has 10,000 elements, it'll take significantly longer to check if the element you're looking for is there. So, in general, you want to use dictionaries when you plan on searching for a specific element. Another interesting difference is the types of values that we can store in lists and dictionaries. In lists, you can store any data type. In dictionaries, we can store any data type for the values, but the keys are restricted to specific types. The reasoning behind which types are allowed can get complex, and we don't want to bog you down with unnecessary details. So as a rule of thumb, you can use any immutable data type, numbers, booleans, strings, and tuples as dictionary keys. On the flip side, like we said, the values associated with keys can be any type, including lists or even other dictionaries. You can use them to represent more complex data structures, like directory trees in a file system. There's a ton of different key value pairs that we need to work with in system administration, so I use dictionaries all the time. They're especially useful with large data sets when I need to write a script that gets specific keys out of it to manipulate or modify the associated value. But it doesn't always need to be that serious. One time, just for fun, I wanted to be able to look up which Disney villain is associated with each protagonist. So I created a dictionary that stores a key like Snow White with the value Evil Queen. Pretty good, right? Mirror, mirror on my screen, who's the best coder you've ever seen? There are even more data types available that we haven't checked out yet. One of these data types is a set, which is a bit like a cross between a list and a dictionary. A set is used when you want to store a bunch of elements and be certain that they're only present once. Elements of a set must also be immutable. You can think of this as the keys of a dictionary with no associated values. Or you could see it as a list where what matters isn't the order of the elements, but whether an element is in the list or not. Wow, we've covered a lot and we've still only scratched the surface of what dictionaries can do in your scripts. As you progress in your IT career, you'll come across a lot of situations where a dictionary is the easiest way to organize your data. If you're interested, you can learn more about dictionaries in the official documentation. You'll find links to this in the next reading. Let's take a second to review what you've accomplished so far. We've now gone over all the basic syntax of Python and then checked out the most common data structures, strings, lists, and dictionaries. These let our scripts do a bunch of cool things like processing text, iterating through elements to do an operation on each, finding out the frequency of an element, and a whole lot more. In the next videos, we're going to focus on a bunch of new concepts. We're going to dive into object-oriented programming, which is a way of thinking about and implementing our code. We'll discuss how to create our own objects and how to use many of Python's interesting capabilities. We're going to learn a lot of new terminology too. Okay, ready for your orientation on object-oriented programming? There's a lot to cover, so let's jump right in. So, how are you doing so far? Is everything making sense? Are all those Apple examples making you hungry? Feel free to pause and grab a snack if that's what you need. We called out earlier that we use methods to get objects to do stuff. We've seen several methods in our examples so far, like lower for strings, append for lists, or values for dictionaries. The key to understanding methods is this. Methods are functions that operate on the attributes of a specific instance of a class. When we call the append method on a list, we're adding an element to the end of that specific list and not to any other lists. When we call the lower method on a string, we're making the contents of that specific string lowercase. How exactly does this happen? Let's take a closer look by defining our own methods. First, we need to define a class and create an instance of it, like we've done before. Nice, we've created a piglet class. While our new piglet might be cute, it can't do a whole lot right now. What if we wanted to give it a voice? For objects to perform actions, they need methods. And as we called out before, a method is a function that operates on a single instance of an object. Let's add a method to our class. You can see here that we start defining a method with the def keyword, just like we would for a function. And see how the line with the def keyword is indented to the right inside the piglet class? That's how we define a function as a method of the class. This function is receiving a parameter called self. This parameter represents the instance that the method is being executed on. Okay, let's try this out and see what happens.
Hamlet equals piglet, hamlet.speak.
And the piglet goes, oink, oink. It sure does, but this makes the piglet say the same thing for all instances of the class. Boring. Let's make the method do something different depending on the attribute of the instance. This time, we've started the body of the class by defining an attribute called name with a default value of piglet. We can change that value later, but it's a good idea to set it now to make sure our variable is initialized. If you look closely at how we wrote the new speak method, you'll see that it's using the value of self.name to know what name to print. This means that it's accessing the attribute name from the current instance of Piglet. Let's try this out.
So we'll set Hamlet equals Piglet. Then we can say Hamlet.name, and we'll set the name to a string, Hamlet. And then we can call .speak on Hamlet.
Meet Hamlet, our Python pig. What, you didn't know pigs could talk? Well, they can in Python. In this example, the speak method printed the name Hamlet, which was the name attribute that we set. What if we create a new instance of the same class, but with a different name? It should generate a different output. Okay, let's try this out. I think Hamlet needs a friend. We've now created two instances of the Piglet class, each of them with their own name. When calling the speak method, each of them prints their name and not the other. Variables that have different values for different instances of the same class are called instance variables, just like the name variable in this example. Since methods are just functions that belong to a specific class, they can work as any other function, so they can receive more parameters and return values if needed. Let's check out what a method returning a value looks like. In this case, we've created a method that converts the age of our piglet to pig years. So the value that the method returns should change when we change the years attribute of our instance. Let's create an instance and check how this method works. Piggy is 2 years old in human years. How old is he in pig years? So, as the value of the years attribute changes, the return value of the pig years method changes too. Coming up, we're going to learn about a few special types of methods, including one in particular called constructor.